So, I'm Mahesh Patel, and I am an assistant professor in civil department and IT Jalandhar. Today, it is my great pleasure for me to welcome all the participants joined through using Google Meet and YouTube live streaming. On the behalf of Department of Civil Engineering and IT Jalandhar, this is the for the workshop. This is TQ sponsored one-day online workshop on application of remote sensing and GIS in civil engineering. And first of all, I would like to welcome our acting head of the department, Dr. H.S. Shore, for providing his precious time from his busy schedule. I am also very our heartfelt welcome our honorable director. He has given his blessings for successfully conducting this course as he could not present due to his busy schedule. I would like to say thank you for his blessings and support. Now I would like to sincere welcome our experts, Professor Hydrological, Professor in Civil Engineering Department, IIT Turkey, Dr. Arpit, scientist in Water Resources Department, IRS Dehradun, and Dr. Gaurav Shukla, he is a faculty in Civil Engineering Department, Maharshi Markandesh University, Morana, Haryana. I also welcome all the respected faculty members of Civil Engineering Department as well as other department of NIT Jalandhar. Now I would like to inform you that we have received tremendous responses of this workshop. That is around 5,000 participants had registered for this workshop, and they are all from different part of India, and some of them the participants are from abroad too. As we sorry, there was a little bit connection problem. Okay, so I think now I am audible. Sorry for the disturbance. So I would like to inform that we have received tremendous responses of this workshop, where around 5,000 participants have registered for this workshop, and all are they from different parts of India, and some of them are from abroad too. So, as we all know, very famous quote, as I am going to brief about this course. Before that, I would like to share one quote, that is, art without engineering is dreaming, and engineering without art is calculating. Okay. So this quote actually given by Robert Watts, that means each and every engineer need to be smart enough to cut the cost of the structure and save the money by using skills, art and calculations. So some of the skills that we will discuss today. So that we know that our civil engineering professional actually a discipline that deals with design, construction, maintenance of the physical and naturally built environment, including works as such building, roads, bridges, canal, dams, airports, sewerage system, pipeline, railways. And nowadays it's very, we can say, responsibility of all the engineer to think about the environment, climate change. So in that case, we need to analyze it, we need to predict it. So also there are some other challenges like with the overcrowding, resources are increased, resources demands are increased. And as city grows, urban environment may face more pressure in their attempt to provide large urban population with sustainable supportive infrastructure. Okay. So in that case, we all need to be together and need to be more to provide the solution of these critical issues. Okay, so in that case, several developing innovations are currently going on and around the world to improve this socio-environmental sustainability. Okay, so there are numerous advances in civil engineering field where GIS and remote sensing playing a vital role in order to simplify the work. And I am not expert in this field, but I can assure that this will help you a lot. So this is just why this we have decided the objective of this workshop to enlighten all the students of BTech, MTech, and research scholars as well as faculty to learn the basics and the importance of GIS and remote sensing, which is having a wide applications in civil engineering, also to train the students with new technologies as per the current requirement of the industries. So these are our objectives. By not taking much time, first of all, I would like to request our Honorable Head of the Department, Dr. H.S. Chore, to say few words about this workshop. So I'm now handing over to Dr. H.S. Chore. Please, sir, say a few words. Chore, sir, I am audible to you?
डिस्कनेक्ट हो गया मुझे 10-50 seconds.
Very good morning to all the participants. This particular TechWeb3 sponsored one-day workshop Am I audible?
Yes, sir, you are audible, sir. Please go ahead, sir.
Okay. Thank you, Mahesh. A very good morning to all of you. This particular TechWeb3 sponsored one-day workshop on applications of remote sensing and GIS in civil engineering organized by the Department of Civil Engineering is aimed at enlightening the students of the undergraduate, postgraduate and research scholars in the field of civil engineering as well as faculty to learn the GIS and remote sensing. This particular field has got a wide applications in civil engineering. Consistent with the time, remote sensing technique has emerged as one of the tools of modern surveying. It has vast applications in the exploration of natural resources, analysis of land use and land cover, information about environment, natural hazard studies such as earthquake, landslide, land subsidence, flood, etc. In a nutshell, this particular technique is of the immense use in various specializations of the civil engineering. So the organizers have chosen the apt topic for this particular workshop. I feel this workshop would be beneficial to all the stakeholders. So without taking much of your time, I request to initiate further proceedings. Thank you.
Thank you so much, sir, for your kind words. And I know that would be very helpful to everyone, but I know some of them will face the problem because of the internet connectivity and some of the other problems. So now I would like to introduce our first speaker, Dr. Gaurav Shukla. and he is currently working as a faculty member in surveying and geometric section, Civil Engineering Department, Maharshi, Markandeeshwar University, Malana, Haryana. And he is also a nodal coordinator of MHRD initiative virtual lab program. And he did postgraduate in geometrics from Indian Institute of Technology, ISM Dhanbad in 2011 and completed his PhD from Indian Institute of Technology, Roorkee. His main research areas include non-parametric approaches of earth parameters, GNSS, reflectometry, remote sensing, and GIS applications. So now I would like to request Dr. Gaurav Shukla to start his presentation, and now I'm handing over to Dr. Shukla. And first of all, I would like to say thank you for joining us. Then please, I would like to request you to please start the presentation. I am now handing over to Gaurav Shukla. First of all, sir, please turn off your microphone. Turn on your microphone, please. The microphone is off.
Yeah.
Yes.
Thank you, Dr. Mahesh, giving me this talk.
Yes, sir. You are audible now.
Okay. As I have learned that there are many participants, so I assume that many of them may be not familiar about the geometric techniques or the spatial technology that terms used for the remote sensing, GIS and GPS. When we are talking about the spatial technology or the geometric techniques, it means we are talking about the remote sensing, GIS and GPS. So these three terms are different. Remote sensing and the GPS is a device to collect the image and the coordinates. Like the remote sensing capture the image remotely, and the GPS can provide the information about the location. It means both are providing some information. However, when we are talking about the GIS, it is a set of tools, hardware and software that can be used to analyze the spatial data. Spatial data means a data that are connected to some geographical location. So I assume that in 5,000 participants, maybe many of them are not aware about the fundamental of the remote sensing. So I would like to start from concept and definitions, sensor used in remote sensing, where you can download the data and their applications. If we have time left, so I will also introduce some part of the GIS. So let's start the fundamental of remote sensing, concept, sensor, data availability and its applications. When we are talking about the remote sensing, it means we are sensing something from remotely. It means we have some sensors which is not in contact with the object and giving me some information which can be analyzed, interpreted and can be find some useful information from these objects. So the definition of the remote sensing is the art and science of obtaining information about an object without physically contact between the object and sensor. The most important thing is without coming into the physical contact between the object and sensor. Means you are not going to the area and you are getting the information. So this is the very important term when you are talking about the remote sensing. So we can, in other words, we can say that we are collecting the information about the Earth surface, phenomena, or the without coming into the physical contact with the surface. Although there is a medium that we call the atmosphere, the radiation comes to the atmosphere, then reflect back and the sensor record the information. It can be also explained as it is a science of acquiring, processing, and interpreting the data. And the data comes from the remote sensors. The interpretation is a different part of the remote sensing, where the expert can analyze the data. Both things is important, data collections and the interpretation. When you are concerning about the data collection, there are the different satellites launched in revolving around the earth to observe the earth's surface. They are giving us a remote sensing images in an image form, also in a different data forms. So these data are not interpretable for a simple person because they are recording the reflectance of the object. Easily we cannot identify the feature just looking the object. If you are not aware about the remote sensing technology and we have not done any representation of the image before. So we need some skill for interpretation. We need some software for finding the information from the image. When we are talking about the remote sensing, there are many other sensors we can see. Like in human body, our eyes are like a remote sensor. When we are reading the book, so it means there is some reflectance interact with the alphabets and the blank surface of the book and comes to our eyes. What our eyes do? Our eyes collect the impulses of the object. The objects are alphabets and the plane surface. After getting these pulses, our brain interpreted it and inform us based on our experience that this one alphabet, this is the blank page, and this is written in a alphabet. So our eyes can be considered as a remote sensor. Our ear is also a remote sensor because when someone say the wave comes to our ear without coming into contact with the human, we are getting the information. That is the main fundamental behind the remote sensors. Other sensors are like instrument camera, like telescope. These are our remote sensors. So our body also has a remote sensor. When we are talking about the history of remote sensing, we can see it has been started in 1850 when we have installed a camera on a balloon and take a picture of the land for getting the information for resource purpose or for the spying other countries. Similarly, we have also used pigeon for this purpose. We mounted a camera on a pigeon and they are the trained pigeon. They capture the landscape and come to the owner. They give the information about the land without going into the contact of the land surface. So it is the remote sensing. We also use kite for photogrammetry. We installed a photo camera on a kite. You can see in the image, like this one image. We have installed a camera like here, and this camera can capture the image where we want to record the image. Then after the development of the aircraft, we install the camera on aircraft and we use this aircraft for photogrammetry and recording the land surface without going into the contact of the surface. After the development of spacecraft, first spacecraft, if we consider in a remote sensing sense, it is a Sputnik launched in 1958. When we are considering the India, We have launched IRS-1A in 1988. So in India, we can consider that remote sensing has been started in 1988 if we are using the Indian satellite data. But if you are using other satellite data, we can say that it is 1972 after the launch of Landsat 1. This was the first satellite that has been launched by the NASA in joint collaboration with the USGS for resource purpose. And this is the data available also free for all users. So it can be considered as a main term in a remote sensing as a year of 1972. So first we should understand how this system works. As we can see, when we are reading in a room and there is no light. If you consider this situation, we are in a black room and there is no light. So what we will do? We will switch on the bulb or we will use the torch. It means when you are reading the book in a black room or without light room, you need some source of energy. Similarly, in a remote sensing, we need some source of energy. What will be the source of energy? It can be a sun, it can be a satellite which has some torch or a instrument for lighting. So first is we need some energy source or illumination. The second is when this radiation goes through the atmosphere, it interacts with the atmosphere. So the second term is interaction with the atmosphere. Third term is when the light comes to the surface of the earth, it will interact with the object, which is the main purpose of remote sensing, to interact with the object. Now, this interaction will reflect back to the satellite, where this radiation that go through the atmosphere also. So there is also interaction with the atmosphere in this phase also. Then it will record by the sensor installed on a satellites. This satellite has captured the reflectance of the objects that are present in the surface. And I will also want to mention that each feature has different signature. That is the main concept which we are analyzing in image. Like if in desk we have a book, like a laptop, we have a bottle, we have a other things. These all objects we have differently for a different wavelength range. This is it means each feature has a signature for some wavelength range. This is the main concept that we are working on when analyzing the images. The third portion is the transmission, reception and processing. Because this satellite only records the reflectance, it needs to transmit for the processing. The last one is the interpretation. That is an important part because everyone cannot read the image. We need some interpreter that are the geometricians or the remote sensing expert which can analyze the image, because the common people only needs a information. They don't worry about the from where you are getting this information. The purpose is only the information. So I have explained that the first is illumination energy source. Means we need some source of energy like a sun or some instrument installed in a satellite which can provide a light which can interact to the object, comes to the sensor, we can record it, we can process it and we can interpret it. So when we are talking about the remote sensing, we the first term that I have told that this is the emission source. That if we are considering the light or the sun rays, this ray has long spectrum of the radiation, ranging from ultraviolet to the microwave, different wavelength range we have in sunlight. But we cannot use each wavelength for remote sensing because in the surface we are not getting each spectrum of the light. We are only getting the longer wavelengths. It means visual and the microwave. Because the spectrum comes from the solar sun goes through the atmosphere. There are different layers of the atmosphere. They trap it. Different wavelength of the electromagnetic spectrum coming from the sun will not come to the surface of the earth. Major higher energy spectrum has been absorbed by the upper layer of the atmosphere. Only the higher wavelength or the lower energy wavelength we are getting in a earth surface. So we can say that we are only working in some specific wavelength range, not a whole range of electromagnetic spectrum. So it is also important part of to understand the electromagnetic spectrum. Which part of the electromagnetic spectrum is used for the remote sensing? This is when, and it also depends on the wavelength. Depending on the wavelength, we also name a remote sensing with a different name, like a visual remote sensing, optical remote sensing, thermal remote sensing, microwave remote sensing, because we are using the different wavelength length bands of the spectrum for the remote sensing purpose. We cannot collect all the information in a single sensor because it is sensor is electronic device. It is designed for some specific purpose. So, and which wavelength we will use depending on the purpose. What is the purpose of the image acquisition? So, depending on the acquisition, we choose the sensor which is operating in some specific spectrum of the wavelength, and from this information we are getting the from these images we are getting the information. So this is also an important part of remote sensing, to understand the spectrum of the electromagnetic wave, in which wavelength we are working, and to understand also, if you will see the image of optical sensor and the microwave sensor, they are different because these wavelengths behave differently with the objects. So we are getting the different scenario when we are changing the spectrum, like our eyes. In our eyes only work in a visual way. So that's why we are seeing the object in their colors. If our eyes extend our range, it will go to from visual to near infrared or thermal. The our scenario will be different because we are our sensor eyes are also getting the infrared spectrum and the thermal range. So same feature will be looked differently. So it all depends on the sensor which we are using. So it is a very simple definition of the electromagnetic spectrum. Like we have an ultraviolet radiation that is mostly absorbed by the upper layer of the atmosphere. The main concern in remote sensing is visual spectrum. The light is our eyes. Our remote sensor can direct is a part of the visual spectrum. The range of the visual spectrum is 0.5 micrometer to 0.7 micrometer. Similarly, after the visual, we have the infrared spectrum, microwave spectrum, and the thermal spectrum. The infrared spectrum has a different thermal band like a 3 to 100 micrometer. So these spectrum like visual spectrum, the infrared spectrum, and the microwave spectrum. These are main concern in a remote sensing because we are only these spectrum for remote sensing purposes. Means we are designing our sensor in a these spectrum because we are getting only these spectrum up to the our surface. Now the second portion. Now when we clear about the object illumination object like a sun or the some source of energy, what will the next? It will the rays will go to the atmosphere. When rays will go to the atmosphere, it can be scattered, it can be absorbed. So we have a atmosphere. In atmosphere we have different size particles. It can be aerosol, it can be water vapor, it can be gaseous particles. So these different particles behave differently with different wavelengths. Like as we go to the upper atmosphere, we have a lighter particles. When we come to the lower atmosphere, we have a higher particles due to their gravity. So wavelength when interact with the object, they can be scattered, they can be absorbed. So this is also an important phenomena when we are studying the remote sensing, because the scattering of the object and the absorption of object depend on the particle that present in the surface of the atmosphere. So when the interaction goes, and it also decide, the atmosphere also decide which wavelength will come to the object. So the object will interact, which will the radiation comes to the earth surface. So there is a different scattering mechanism and absorption mechanism. Like in scattering, we have I think most of you have read this scattering phenomena in intermediate classes, like Rayleigh scattering, my scattering, and non-selective scattering. So these different scattering.
Dr. Sapna, sorry to interrupt.
Yes, sir.
I think your presentation is unpinned now. So please go to Google Meet and pin your presentation. Just maybe there is not showing the presentation.
Thank you for information.
No, you have to go to the people, and people
Yes,
you will get two names.
Region
One is presenting. Huh?
Yes, yes, region presenting.
Yes, yes. Okay, thank you.
We have three types of scattering: Rayleigh scattering, my scattering, and non-selective scattering. And these scattering are these phenomena that occurs in the atmosphere depending on the size of the atmosphere particle. So they occur at a different level of the atmosphere. Like when we are talking about the Rayleigh scattering, it occurs at the upper atmosphere where the particle size are smaller than the wavelength. It means Rayleigh scattering causes shorter wavelength of energy to be scattered much more than the longer wavelength. It occurs when particles are very small compared to the wavelength of the radiations. Because the upper atmosphere has the particles which are very small in size. And if wavelength is longer than the particle size, it will interact with the particle, and this is called the Rayleigh scattering. This is also a main cause of at sun and sunset, the light has to travel further through the atmosphere than at a midway, and the scattering of the shorter wavelength is more complete. This leaves a better proportion of the longer wavelength to penetrate the atmosphere and sky appear red. When you look at the clear sky, you see all the scattered light. When you look at the sunset, the light that makes it to you as what left, mostly yellow and orange. This is the main phenomena that governs the Earth atmosphere when we are seeing the surface from the surface. In my scattering, the particles are just about the same size as the wavelength of the radiation. Dust, pollen, smoke, water vapor, and the common causes of the mice scattering. It means when we come to the from our to the lower atmosphere, the particles exist in this atmosphere. Here the particle size is nearly same to the wavelength of the coming radiation. So there is the mild scattering, then now selective scattering means the particles are much larger than the wavelength of the radiation. Water droplets and the larger dust particle can cause this type of scattering. Non-selective scattering mostly occurs at the lower portion of the atmosphere. So, second, now when we know that this is the scattering, now the third portion is the absorption. It means when the radiation comes to the atmosphere, it interacts with the objects, means particles in atmosphere. It can be scattered, it can be absorbed. So some particles like ozone, carbon dioxide, water vapor are the main source of absorbing the energy. So it means we are getting only some portion of the coming radiation. That is the main purpose. Means which one is coming to the objects, up to the object. There is the image which is showing like this one. In this one we can see a transmission in visual range is 100%. It means the visual range radiation from coming from the sun to the earth is coming in a full form, not a fraction. Like in an ultraviolet, you can see most of the wavelengths, like in this one portion, most of the wavelengths have been absorbed or scattered. Only this portion, visible, near infrared, and in last, if you can see, the microwave. It means we are only getting, we have some window in a spectrum, which radiation coming from this window only can interact with the object. We cannot use our wavelength of the sun radiation for the remote sensing purpose. So this indicates that we need to speak about the sensor spectrum. Depending on the platform, we can classify the remote sensing in 3 types, like ground-based remote sensing, airborne remote sensing, and the spaceborne remote sensing. Initially, we have used like aircraft, where we have a capability to launch a satellite. We have a spaceborne platform. We also use some remote sensors in a ground-based platform. You have seen sometimes that some vehicle had mounted some sensor on their surface and record the information surrounding the earth. Like we are using the lidar. When we are using lidar, it can be mounted in some vehicles. It can be mounted in some stand. So these are some ground-based platforms. In airborne platform, we are installing the camera, we are installing the sensors in a platform which is floating about 1 to 10 kilometers from the surface, like a drone, aircraft. These are the some airborne platform we are using for this purpose. And in space platform, space-based platform means we are launching some satellite for this purpose, and we are evaluate this satellite with some sensors. This sensor record the information from the surface. They will send this information to some center on Earth. This center will analyze the data and provide to the some analyzing institute like NRSC. NRSC is an organization in India which has a record of all remote sensing data. it provides they are also interpreting the data, they are filtering the data, they are correcting the data and providing to the different analyzing person like academicians, different institutes are analyzing these images. The ground-based platform, as I told, the ground observation platform are used to record detailed information about the object or the feature of the Earth's surface, because we are using the sensor in a near to surface, so we are getting the detailed information of the object in comparison to the aircraft or the space, which are in a higher altitude. So we can see that we are using crane, we are using vehicles, towers, we are using the stands. Some are, you have, I think you have seen that spectroradiometer. It is also a remote sensor in a ground-based platform. In airborne platform, we are using drones, we are using aircraft, we are installing the camera, we are installing the sensor on a bottom of the aircraft, and by proper planning of the aircraft, we can capture the whole area through the whole area, and these information can be interpreted later. Like in a drone, we can install a sensor like LiDAR, we can install an optical sensor, we can install a thermal, we can install a microwave. If you planning for buy the, when you are planning to buy the drone, they also need some information about the mounted sensors, because they are capable only to carry some weight. So if the weight of the sensor is high, so maybe some drone will not work. So if you want to purchase these things, we need to compare both factors in purchasing these sensors and the aircrafts. In space drone platform, as I have told, it had been started in 1957, with start of the Sputnik first. But we can say that in 1972, after the launch of Landsat 1 for the resource management, we are using the images of Landsat 1, the series of Landsats. In India, we can tell that after launching on IRS-1, Indian Remote Sensing Satellite 1A, in 1980, we have started the remote sensing from the space. So we have learned that based on the platform, there are three types of remote sensing: ground-based, space, and aircraft-based, and the space-based. Based on the illumination source of energy, we can classify it in a two types, like active remote sensing and the passive remote sensing. When we are using the sun as a source of energy, we are using the passive remote sensing. Active means we have own source of energy. Means our satellite has some source of energy to transmit the radiation to the surface of the Earth to record the observation. But when we are talking about the optical remote sensing, thermal remote sensing, most of the sensors are only passive in nature. It means we are using the sun as the source of energy. But when we go to the microwave remote sensing, most of the sensors which we are analyzing active mode, because the microwave is a lower energy wavelength, lower energy and higher wavelength. So we need some source of energy that can push it up to the Earth. Because the radiation coming from the sun, the microwave radiation coming from the sun may be disturbed by the atmosphere particle, and the sensor cannot get any response from the object in a microwave region. So in a microwave region, we need some source of energy. We are designing the sensors which can transmit the radiation or the energy to the object. They reflect that to the sensor, and our sensor record these pulses. So both are different, microwave response and if you are talking about the optical response, both are different. In a when you are seeing the image also, and when you are interpreting it. So both scenarios are different. So we can learn that we have two classification of remote sensing if we are talking about the source of energy. This is the active remote sensing and the passive remote sensing. When we are talking about the spectral band, so we can classify the remote sensing in the three classes, like visible and near infrared remote sensing, or we call it as a optical remote sensing, thermal remote sensing, and microwave remote sensing. Both three images are different in if you are interpreting the images or if you are only viewing the images. Just you can feel it like our eyes. When our eyes work in a visual way, it will have a different response than in thermal or in a microwave. So similarly, because the sensor are recording these different wavelengths, they have recorded some different pattern. So interpretation and the visual interpretation, both are different in these ranges. So mostly we are working in a visual band for resource management, thermal for disaster management, like if there is a fire in a forest area, so we are using the thermal images. If there are diseases like malaria or if we talk about the corona, so main symptom is the rising temperature. It means if there is some area critical for a coronavirus, it means there are just different bodies which emit more from their normal. So their radiation will be more in comparison to the normal days. So we can also identify from thermal images the prone area of these virus or the malaria. There are different studies also that present thermal image useful for decision monitoring. In microwave remote sensing, the microwave remote sensing is in comparison to the thermal and visual region has some benefits. Like microwave radiation can penetrate to the cloud and maybe not disturbed by the haze, maybe not disturbed by the plume, maybe not disturbed by the heavy rain. So depending on the microwave wavelength band, because we have a different wavelength band in the microwave range also. So depending on this wavelength band, we have a different phenomena with the interaction with the cloud, haze and plume and the rain. But visual and thermal images are these two images are trapped by the cloud. So in visual and when we are talking about the thermal, we maybe have a cloud images. If there is a cloud, it cannot penetrate, the radiation cannot penetrate to the cloud. So we are getting the information of the cloud, and we are not getting the information of the object beneath the cloud. So in a visual range, main criteria when we are taking the image is a cloud cover. But when we are talking about the microwave, this is not a main topic. Means not a we don't worry about the cloud cover. So in a rainy season or in a summer when there is a more clouds in a atmosphere, we can take the microwave remote sensing, and it also has one benefits like penetration capability. Microwave can penetrate to the earth So it is mostly used for the soil moisture measurement. So this capability is also important part of the microwave remote sensing. In visual range, you can see that the Karnal district is shown in a Landsat image. The Landsat is a satellite that has been launched by USA and USGS. It has a series of satellites actually. So you can see features are different in when you are seeing it. So visual interpretation is very important when you are seeing the image. So common user who don't know about the remote sensing cannot easily interpret these images, because this one area is the urban area. Means the lighter response is corresponding to the concrete structures. So we can say that this is the city. And if we talk about this one, this is the linear feature. We can say that this is a highway or the concrete roads. These all are some villages lighter. But when we are talking about this reddish region, it means there are some farmlands, agricultural lands surrounding. So in this Landsat image, the red color in a two-color composition is showing the vegetation, and this one area, the latter one, is the urban area or the some settlements. And in visual range, we are working it from 0.3 to the 3 micrometer area. The magnitude of the reflection interprets the condition of the land surface, plant species and their distribution, forest, farm field, river, lake, urban area. I have told that the interaction or the response coming from the object depend on the physical property, chemical property of the object. So it means each object has some different signature when sensor is recording. So we can analyze this signature, and we have some previous knowledge about this signature. So we can easily interpret different features from the images. In thermal remote sensing, you can see the landscape is seen like this one. It is thermal images, because we are recording only the thermal waves. So there is some hot points, there is some low hot points. So these low hot points indicate there is a cooler body, means like a water body. If we talk about this reddish area, so we can say that this is the some settlements, because the urban area has more heat in comparison to the forest area or the water body. So in thermal images, we can also interpret different features. But the knowledge of remote sensing is required when interpreting the image. Just seeing the images, you cannot tell what is these bodies. So we need some interpretation skills. In microwave remote sensing, we are working from wavelength 1 centimeter to the 1 meter. These are the longer wavelength, means the lower energy. So I have told that most of the microwave remote sensing sensors are active in nature, means they have some energy source. They send the energy to the object, then this energy travel back to the sensor. And this sensor in a satellite will record the response. We are actually recording the back scattering of the object. Back scattering means just go to the object, the beam go to the object and just back to the sensor. This is the back scattering of the object. So you can find that the images are different in comparison to the thermal images and the optical images. These are the some spot images, radar set and the pulsar. These are the some microwave satellites, and the images shows that the cluster of the points only. You cannot easily define the object in a mimicrowave remote sensing. it is a visual interpretation is a very tough task in a microwave remote sensing. However, in a optical or in a thermal, you can analyze it. But in a radar set, thermal or microwave remote sensing, you cannot easily analyze different features. So it requires more skill in a remote sensing observations and the practice in a remote, microwave images. And mostly microwave remote images are used for agricultural land monitoring, their soil moisture monitoring due to their penetration capability. Remote sensing sensors. Now we can know that we have three platforms. We have active and passive remote sensing, and there is a different spectrum of the remote sensing. Now we can consider the sensors which are recording these pulses. So sensor is an electronic circuit which can be record the electromagnetic radiation. All sensors employed under Earth observation platform use electromagnetic radiation. Hello? Yes. All sensors employed on the Earth observation platform use electromagnetic radiation to observe the terrain feature. Various types of sensors are employed based on the requirement and the purpose. So I have listed based on the electromagnetic radiations or the type of remote sensing, like illumination sources. They are passive in nature and the active in nature. Passive in nature means you are using the sunlight, and active sensor means you are using the own source of energy in a sensor. Here I have listed some of the sensors from where we can get a free of cost images. I have not listed many of them which are which are need to purchase. These all are free of cost. You can just order these images from their website. There are I will show in other PPTs how you can download these images. So if you go to the, however, there are many remote sensing satellites. I have listed some of them only. So like Landsat. When we are talking about the Landsat, it is a series of Earth observing satellite missions jointly managed by the NASA and US Geological Survey. It has a 9 satellite. It has a 8 satellite from Landsat 1 to the Landsat 8. The recent Landsat was Landsat 8. It was launched in 2013. They are planning to launch Landsat 9 in April 2019. April 2021. So they had launched in 1971 the Landsat 1. From the series of Landsat, they are covering the Earth. They are providing the free of cost data and in a better resolution, in a like a 30 meter, 20 meter resolution. So you can, most of the research you can find in a literature that they are using the Landsat image before the Sentinel-1 launched. When the Sentinel-1 launched, due to their radiometric and the geometric enhanced capability in comparison to the Landsat, now most of some researchers are using the Sentinel data also. So Landsat in this satellite also providing us images, also providing the default products like surface temperature, NDVI, and the vegetation land cover surfaces. So one by one, if you see the AVHR, the Advanced Very High Resolution Radiometer Sensor, it is mounted on a NOVA satellite launched in 1978. But it can also advance default product such as a surface temperature and NDVI at a 4 kilometer spacing. You can see that the AVHR sensor also provide NDVI data. NDVI is a representation of the biomass present in the surface. Means if there is a vegetation, higher vegetation, green vegetation, NDVI will be the NDVI value will be the higher. So it represents the biomass present in the surface. So AVHR also provide the default product of NDVI. Surface temperature also at a resolution of 4 kilometer. Because when we are talking about the surface temperature, soil moisture, actually the purpose is the global. Weather monitoring, energy cycling monitoring, water set monitoring. So these resolutions are fit for these purposes. However, we have a different satellite which has a lower resolution, but really they are not free. MODIS is also called moderate resolution imaging spectrometer. It is a instrument about at the Terra satellite. Terra and Aqua. Terra and Aqua has been launched by the NASA and USGS for the resource monitoring, for the climate monitoring, for the like temperature, surface temperature monitoring, and the vegetation health monitoring. So MODIS also provide the NDVI value, means the default products, and the surface temperature value at a resolution of good resolution in comparison to the AVHR, the previous launch, at a 1 kilometer. Similar, if we go to the SMR and the SSMI, the scanning multi-channel airborne radio meter and the SSMI both had been installed in a Nimbus satellite, and these are the SAR data, actually the microwave data. So the SSMR provide C band at 150 kilometer resolution. SSMI provide the wetness, rainfall, and the cloud. Similarly, we can see that MSR and the SMAT, these all are
Dr. Subra, sorry.
all are sensors.
Again, there is a sad problem. I think this presentation mode has gone. Let's click on that presentation.
Okay. Now it is okay?
Yes. Yes, now it's okay. Thank you.
Oh, thank you. Thank you. And we can also see the TRM and the GPM. You can be surprised that the GPM provide the precipitation value, and the TRM also provide the precipitation value at 25 kilometer. In each 3 hours, means in any location you can get the precipitation value at each 3 hours. And GPM also provide at each 30-minute repetition at a 10 kilometer resolution. So you can easily imagine that these data like precipitation, surface temperature, like soil moisture are very important when we are working in hydrological modeling, when we are working in environment modeling, or weather forecasting. So these data are free of cost. You can use and you can make your model for future prediction. And the important one, the GRACE. The GRACE provides the groundwater capacity of the groundwater in the earth surface based on the gravity. The GRACE measures the gravity value of the earth surface. Based on the difference in gravity, they inform us about the groundwater availability in a region. So GRACE is also GRACE is an important aspect in a hydrological modeling. So, and the ARIS, it provides the water vapor profile, air temperature profile, surface temperature at a 12.5 kilometer. All these satellites, if you see, that provide the information like precipitation, temperature, and the wetness, rainfall, vegetation also. So these are some parameters that are used in a hydrological modeling, weather forecasting. So this is not new. There are different models also available which use input of these satellites for weather predicting, for the groundwater monitoring or the modeling. So you can easily download these data from a site available, and you can use these data as an input for your models. When we are talking about the Indian satellite system, we can see that it started in 1988 with IRS-1A launch. IRS-1A was launched with some modification in 2013, that is called the IRS-1B. The ocean set, actually different satellite has been launched for different purpose also. And they install the sensor also depending on the purposes. Like if our purpose is a resource monitoring, they have installed the land surface monitoring, they have installed some different sensor. In comparison to if they want to record the information from the ocean or from the clouds or from the atmosphere, they have different sensor for different purposes. So similarly, Indian ISRO has launched the ocean set. This was the first ocean monitoring sensor installed in the ocean set first in 1991. With better capability, they launched the ocean set 2 in 2019. The resource set and resource set 1 and resource set 2. These are the series of the IRS 1C, 1D and other satellites.
Sir, please share the PPT. Someone has interrupted me.
Okay, again.
Please go ahead, sir.
Yes, sir. Yes, we are talking about the Indian satellites. Then in 1998, we have launched the IRS-1. This is the first satellite launched by the ISRO for the remote sensing purpose. However, we have launched Arpit also other satellites in the previous years, but the purpose was not remote sensing measurements. We have talked about the ocean set, and we are talking about the resource set 1 and resource set 2. These are the satellite launched in series of 1C, 1D and 1A with better sensor capability. The launching of the satellite in continuation means we have advanced technology now. Means we have advanced sensors, we have advanced capability for interpretation. So we are launching the satellite for same purpose with better geometric and other capabilities. If we are talking about the cartography, these are for the topographical mapping, and you can surprise that it has a resolution of 2.5 meters to less than 1 meter. Means you can observe even a single car, even up to 1 meter length from the satellite. So the Cartosat 1, Cartosat 2, Cartosat 2B, these are the some Cartosat range, satellite for topographical mapping or for the data creation, because digital elevation model is important for when we are working in the hydrological modeling and for any planning of the city. The undulation in the earth is important. So digital elevation model is an important factor when we are talking about the when we are working in these areas. So Cartosat 1, and it is also supplied that this data is free of cost. You can download it from ISRO satellite, from the other satellites, from ISRO link or the other link available to download these satellites. And the first Indian microwave remote sensing satellite is the recent one. In 2012, it was launched by the ISRO. It had C-band sensor. Means this is working in a 5.3 gigahertz frequency. This is the first Indian satellite launched with the microwave capabilities. And it is if you think about the data, it is a very cheaper. Means one scene is about 5,000 only. So, and one scene is a very big area, like a 200 kilometer by 200 kilometers. So you can purchase and use the SAR data also. This is the commercial satellite research one up to this date. But there are many microwave satellites like Sentinel-2, which has also a microwave capability with a dual polarization. You can use also this free of cost satellite for when we are analyzing the microwave data. Then INSET is designed for meteorological observation. We have a INSET series, INSET 3A, INSET 3D. These are for meteorological purpose. We have a sensor that record the information about the climate, and they predict the weather information like raining or the other cloud. These are the some information they provide to the sensors. And the SAR, this is launched in 2013. It is a joint project of the French Space Application Center and the Indian Space Application Center. And this is the main purpose of this satellite is ocean monitoring, like a ocean set. But because ocean set was known by the ISRO only, but in this SAR project we have involved the French Space Application Center for ocean monitoring, and it is launched in 2013 in comparison to the ocean set launched in 1991. It means they have a better capability of sensing in comparison to the previous one. So you can consider all these data provided by the Indian Space Application Center for your resource monitoring, for weather monitoring, your climate prediction, your other any purpose you can use these data. Now we can go to the application of remote sensing. Here is a one case study of Iraq. It is a very rare to have wetland in an arid region. Iraq also has a Mesopotamian marshlands. It means it is a largest wetland in the Arabic world. So it is a very important feature available in an Iraq which need to analyze regularly. So we can understand the impact of human in these bodies. So we can see 1985 images, 1989, 1994 images, 1980, 2004 and the 2009. The red portion or the pink portion are the vegetations. The water bodies are the blue, and the bare land is the white and grey scale. So you can easily see the vegetation portion is depleted throughout the years, and these vegetation are in the wetlands, means they support the aquatic life in these wetland. It means if vegetation is depleted, it means there is a decrease in the size of wetland. This is a major concern for any environmentalist or for anyone to analyze the impact of human in these resources. These are the resources because wildlife or the aquatic life depend on these wetlands. you can see here also, we had Lancet image from 1985 to the 2019, and the NDVI of AVGR data. This is the of 1 kilometer resolution, this data, this one. And this is the Lancet image. And we classified these images of different year in 3 classes: water, vegetation, and the barren area. We can easily see that vegetation is reflected throughout the years. It means we are losing our wetland area in Mesopotamia, which is the largest wetland in Arabic region. So this is also concern of environmentalists, and you can analyze also in NDVI of AVGR data, which is the above data Lancet is a 30 meter resolution. However, this is of 1 kilometer resolution, but the results are similar. You can see there is you can see there is a increase in the bare lands or the barren area. So these are some benefits of the remote sensing images. You can have different year images for analyzing the past and for the present also, and you can plan based on these information. So for resource mapping, we are also using the remote sensing. You can see in these images, this is the forest land, Smoky Mountain of the southern United States, change color from brown to orange to green to brown as the season progresses. From fall to winter to the spring and summer, we can analyze these areas. And from this information we can predict the vegetation cover, their health. So these are the important parameters when we are working on the resource monitoring. Like if you are in agriculturist, our concern is to vegetation health. So from remote sensing sensor we can get the agriculture health also. From we can also see, we can map a land cover and land use map. Like in this Bardhaman area, we have a land cover and land use map of the area using the remote sensing satellite Landsat 7, I think, and 30 meter resolution. And what is the importance of these? On this classification, we can only manage our lands for better other purposes. Like if you want to construct some building, we need some space. We cannot put a building in an agricultural field or resource fields, which are more important than the building. So for better understanding of the area, we need some classified image, and we can classify the different satellite image in different land cover classes. We can also have a soil texture information by the classification. We can classify the image in a soil cluster. So remote sensing images can be used for different purposes depending on your objective. Like terrestrial and climate parameter mapping, you can see global change in a normalized difference vegetation index from 2010 to 2017. So it is only possible if you have the previous recording as a remote sensing sensor. It is not possible to record in a copy or make some database in a file. You need some images to analyze from previous year, from the recent year. So this is showing how our NDI, I have told, this is a biomass that indicate the greenness present in an area. So you can see the India also, you can see the other area at different season they are changing. So for global monitoring, this is an important tool. Remote sensing is an important tool. Like surface soil moisture, You can monitor the surface soil moisture from previous year to the latest one. So for global purposes, these are the important parameters when you are considering the hydrological modeling, when you are concerning about the weather forecasting or the agricultural land also. The precipitation. The precipitation is also can be predicted through different satellites like a TRL and the GPM. So you can get a millimeter precipitation per month, and it is showing the precipitation of the different year in a northern and southern hemisphere. The liquid water thickness. You can also measure the liquid water thickness. It is also important parameter when you are working in hydrology modeling. So these are the some now the disaster management. How you can manage the disaster when you have a real scene of the landscape. You can manage it. Like it is showing the Kedarnath images before the disaster and after the disaster. If the planner has both images, he can easily identify the differences. The more vulnerable area, the more disaster area. So if the planner knows where we need to input our resources, so it can be better plan instead of going to the site. So this is also important factors. You can see in a Sukkur district of Pakistan, they identify the loss of standing crop through the satellite images. This is the previous year, pre-flood satellite image in 17 July 2006 and the post-flood 09 August 2006. You can see the disaster area. So you can easily predict the loss of the agricultural lands. This is important when you are facing the disaster, not only flood or in earthquake region or any disaster phenomena. You need some engine to represent the real picture of the area to analyze the data. So it is a very important tool. In infrastructure development, you can also use satellite images for infrastructure development, because when you know where is the open land, what is the other landscapes, you can better plan the city. If you don't know, if you talk about the Punjab, if you don't know where is the open land, where is the agricultural land, where is the settlements, or where is the river or other water body, you cannot just tell that there should be the one mall or there should be one school or there should be one stopper. So you need to know about your resources available at a land to better planning. So you can see in this city they have planned from 2035. Based on the 2005 images, because they know where is the open land, where can be settled a school, where can be settled a mall, or where can be a office. So better planning, you need some engine that is only possible in a remote sensing engine, because the area is very large. It is not possible through the manual observations. Like this one is a recent topic, like one river valley. We are facing the conflict with China. So you can easily see pre-conflict or 22 May 2020 image. There is no settlement in the valley. But after a conflict, we have a large settlements. This one. From images, this area is not accessible to the daily foreign groups or any persons. So from the images you can get the information where the troop movements, where the settlement, where the disturbances. So you can prepare according to these activities. Now we will go through the how you are downloading the data, because the data is important. Now you should know where you can approach to get a data, and those are free. So you can get the data. So first is a important site is the GIS Earth Explorer. Here is also a link, and you need to first register here. After registering, you need to select the area. Like here I have selected the Jalandhar region. This is the Jalandhar region, and the all is the urban area. It is it means there is a much infrastructures. It is a city. So just type a Jalandhar region. You can also provide a save files. This is showing the Jalandhar region coordinates. You need to provide the date range from where you want to the from where to where you want to satellite images. I have given here. Then you need to select different data sets which you want for your purpose. There are different data sets. You can see here, like a digital elevation data, digital map, global ISA, land cover, land set data, NASA radar, Sentinel, VSA. These are different satellite data available in this site. So in this case, I have told that the Landsat is important. So in the Landsat collection, they are showing different Landsat version. Landsat 1 to Landsat 8. So you can select any one or all of these satellite data for downloading. And when you search your observation, they will show images available into this region, like in Jalandhar region. So these are the images of the Landsat 8 available of 8 July 2020 and 15 June 2020. So you can download easily from this menu. Other link for downloading the satellite is GIS. This is also giving the here also giving the link. You can select the different satellite. You can select the region, and the same process is same. First you need to select the region where from to get the data. You need to select the data set, and you can just download it. And third one is the Earth data, where you can find different satellite sensor like IRS-1C. This is Indian satellite of the region. So you can download the data, but you need to only register it. These data are free of cost. Copernicus Open Access Hub, it is mainly for Sentinel-1, Sentinel-2 and Sentinel-3 satellite. So you can download Sentinel-1, Sentinel-2, Sentinel-2 is a microwave satellite from these links. And this is the ISRO satellite 1. You can get the different satellite data free of cost like OceanSat-2, SkySat, ResourceSat, IMS, Cartosat, and ResourceSat 1 and 2. These are the free data available in these satellites of the region, Indian region only. They also provide the thematic product, like I have told that default products like land and terrain, ocean physics, land vegetation. So you can select these features if you want to map to get the map of this area. So thank you very much. If any query, please you can also contact me, and you can also call me here also.
Thank you so much, Dr. Gaurav Shukla, and
Yes.
for your very good presentation. And it is very informative, and where you have explained the basics of GIS, and also you have explained a very good thing that our eye is also working like a GIS. That is also actually sensing the data. So that also you have explained how to apply that knowledge in suppose for example land cover changes, hydrologic modeling, and how to get the data. I think this will be helpful for the beginner, those who are actually recently started working on GIS and remote sensing. So I have actually taken some of the questions from
Yes, please.
their chat box. So I'll let you know some of them.
Yes.
Some of them are asking what is multi-spectral scanner.
Actually, multi-scanner is a different, as I told, the range of spectrum is important when you are observing the object. So multi-spectral scanner means you are having different band wavelengths. It not easily installed in the Lancet one. When they have a visual range from point 4 to point 5, point 5 to point 6, point 6 to point 7. So these band ranges are the multi-spectral. Means different spectral range of the wavelength band. When you have in a one sensor, this is called the multispectral bands. Sensor.
Okay. And there is one more question from Arpit, and he's asking about how can remote sensing in GIS be helpful in glaciology, and how can we differentiate the surface layer of glaciers where the ice or where is the snow with the help of satellite images?
Yes. Actually, when you are working in a glacier, so actually satellite is taking the image of the landscape. It can be ocean, it can be a land surface, agricultural land, it can be glacier. Because different objects interact differently. So glacier, the ice object also differently with the different wavelengths. So you can use this satellite images for glacier monitoring, like glacier deflection. I have seen one study in 2019 that study was on a glacier deflection. Means they are observing the glacier origin, and they seeing that the origin is descending towards the glacier. So they can predict that the glacier is melting more. If glacier is melting, it means the what is going towards some bodies, water bodies like river, like ocean, it means there is challenge, means there is some environmental changes. Yes,
Okay, sir. And there is one question from Vandana Mahito,
yes.
and she's asking about apart from trace, where can I get the data for groundwater?
Drone. Yeah.
Yes, trace. There's we can get the groundwater data for 100 kilometer, and if we want the she's asking about there is other source or other website where we can get the groundwater data.
Actually, groundwater data is in remote sensing. It is only one that is a GRACE, which is providing the data in of groundwater. But when your concern is very limited to some area, it is only possible in field observation. You can get from the water resource departments. They have a field data of their well of groundwater. So if you in remote sensing, you have to depend on only coarse resolution or the very high, 1 kilometer or 2 kilometer resolution for the groundwater when you are depending on the satellite in a case. Yes.
So I'm also searching if there is since simple. I think there are some. Most of them are saying thank you. And Mahesh Kodekar is asking about RS remote sensing is useful for only surface characteristics or even surface can be detected. I think there is the same question that you have already given the answer. And now there is a Mohammed Rehan Ansari. He is asking about since microwave has highest penetration through atmosphere, why is it not used for all purpose study rather than working only in visible range of spectrum?
Interpretation and scattering, to understand the scattering is a very difficult task. So, when we are going to the microwave remote sensing, the visual interpretation and the software interpretation both are very tough because they are recording the scattering, not the reflectors. So, to analyze this scattering, is a recent work and researchers are working on the technology. But optical, because in optical sensing, we have launched in 1972. From 1972 to 2020, we have an advanced development. So we have a different tools to analyze data, we have a different skills. But in microwave, which is launched in the recent years, so data is different from the optical sensing. So this is a research work for new students and faculty members to how we can use remote sensing for many other purposes, but mostly they are using for soil moisture measurement when water is up to surface. If there is a dry condition, and the microwave penetration is about 1 kilometer. One study showed that Saraswati River also, Saraswati River, which is beneath the surface, is also identified through the microwave sensors.
Okay, thank you, sir. So I am taking on the last question. This very basic question when asked by Kutkum. He is asking about what is the difference between vector and raster data.
Actually, this is the remote sensing data. When we are talking about the GIS, we are working in a vector and the raster data. Raster data is the image data. When you are digitizing it, it is a vector data. Means remote sensing data is a raster, but when you identify the feature and you digitize it, it is a vector. We are working actually, we are using remote sensing data, means vector data, but purpose is to convert it in vector data. So we can use GIS tool for further purposes.
Okay, thank you so much, sir. And you have explained all the doubts. I think I have taken most of the questions related to your topic, and you have explained it very in a nice way. So I think most of them have got the answer. And if you will face further any problem, you can send an email to Dr. Gaurav Shukla, and you can discuss with him whatever the doubt you are having in the future.
Yeah.
And also, thank you so much, sir, once again. And now we will take 20 minutes break. But before that, I would like to announce that we are also working. Some of them are facing about the voice problem, so we are going to sort it out. And those who are asking about the attendance feedback, you just keep logging on your system and keep posting the lectures. That attendance will be recorded automatically. So do not worry about it. Okay, and whatever the concerns that we will actually discuss. So I am asking you to join at 11:55. So I think now my voice is actually clear. So now I would like to introduce our second speaker, Dr. Arpit Chokse, and he is currently working as a scientist in Water Resources Department in Indian Institute of Remote Sensing, Dehradun. He did his post-graduation in Water Resources Engineering and Management from Indian Institute of Technology, Guwahati in 2010. By following that, he has joined the PhD in the same institute. In the meantime, he has obtained IRS Dehradun as a scientist in 2013, and it's very less to talk about him. He has received it's very lot to talk about him, but I will explain in a very less phrases. Like he has received various awards in his career, namely Best Himalayan Explorer by Explorer Himalayan Solar Powerhouse, Mahanadi, Himachal Pradesh. And he has received also other awards that I am not taking their name because their list is very long. And he is very hardworking in his areas, and he has done a lot of work, and he has published many research papers and done many projects. Now I would like to request Dr. Chokse to start the presentation, and now I am handing it over to you, Dr. Chokse, please.
Hello, thank you.
And I am also requesting other people to please turn off your video and mic so that you can attend the session easily. Okay, thank you.
Yeah, thank you, Dr. Mahesh. Am I audible to you?
Yes, sir, you are audible. Attend the session.
I can't present because some Zubair Bangaru is presenting now.
Dr. Raji, please remove these participants, those who are actually clicking on present now.
Okay, now it is coming. I hope my PPT is visible to all.
No, sir, not PPT yet. I think you have to share.
Yeah, I have shared. Is it not visible?
And you have to pin that PPT. You have to pin that PPT on the people, and then you will go to the people, and then you will get your name. You can click on present now.
Yeah,
At the lower right corner, you can click on present now.
My screen is visible now.
It is going to be presenting. Yes, sir. Now it is presenting.
Now the PPT has come.
Yes, sir. Now PPT has come.
Okay. So good afternoon to all the presentees here. So today's topic of the lecture is overview of geospatial technology for hydrological modeling. Dr. Mahesh, please stop me if my audio is not coming well.
Sure, sir. I will stop you in the
Okay. So let's talk about the overview of geospatial technology for hydrological modeling. So first, let us start with the hydrological modeling, hydrological cycle. So as everybody on the earth is well aware about the hydrological cycle, what are the components and how it propagates. So just for the briefing, I'll just start with the precipitation. When the cloud condensed and it uh, precipitates in a form of rainfall or snowfall, or there are many ways of the precipitation. So suppose snowmelt runoff is there or rainfall is there. So the second parameter, I have encircled the parameters with the red circle. So interception will take place. Interception means the part of the rainfall which gets intercepted by the plants, trees, or the litters. So these are called the interceptions, which are the part left behind over the soil, and the part which is not left over the soil, that goes for the infiltration or percolation and later joins with the soil moisture or subsurface flow or the under groundwater flow, and the intercepted water gets evaporated back to the atmosphere by several ways like transpiration from vegetation, from soil, from surface water, from streams and lakes, and from oceans. And the remaining part, after this all the water balancing has been done, precipitation minus interception minus evaporation minus soil moisture storage minus groundwater flow, the part left behind is called the runoff, what we get in the streams and the rivers in form of the discharge. So now my next question is why we need to do the hydrological modeling. So because why we need to do the study the hydrological cycle. As you have seen there, India is a very large country and very much diversity of the climatic variations are there, like heavy rainfall is there, some part of the country is scarce in the rainfall pattern. So many casualties or disasters has happening because of the hydrological cycle, like heavy rainfall creates the dam breaks, breaching of embankments, drainage congestions, storm surge, glacier lake outbursts. So to mitigate, to predict, or to manage these type of activity, we need to study the hydrological cycle. So there is a vast difference between the natural hazards to disasters. So these terms I have just spoken, like heavy rainfall, droughts, and others. These are called as the natural disasters. But when these natural hazards converts to the disasters when it gets the people residing over the certain area gets affected by these natural hazards. So if an earthquake comes in a particular area, then it will be a natural hazard. When the earthquake comes at a area where people are getting affected or the infrastructure is getting affected, then it will be called as a major disasters. So there is a difference between the natural hazards and disasters. So now three question arises out of this, that can we stop these disasters? Can we predict? Can we manage or mitigate? The answer to first question is no, we can't stop the natural hazards or the natural disasters. These are going to happen naturally. Can we predict? Yes, of course, to some extent we can predict these natural hazards and disasters. And while predicting, we can manage and mitigate them. But what are the gap areas are there? The main gap area is the communication. We can't have the communication. Real time data is not available for the analysis of the extent and damage assessment and road connectivities to evacuate the people, or day-to-day monitoring of the events, alternative routes for the rescue and relief. So forecasting and prediction and operation is the only way to help to manage and mitigate the disasters. But how to do that? That is the main question. So the answer of how is the hydrological modeling. Hydrological modeling is nothing but the simplification of the real world system that adds in the understanding, predicting and managing of the water resources. It involves the application of mathematical expressions that define quantitative relationship between inputs, that is our rainfall, and outputs, that is the flow characteristics. So why we need to do the hydrological modeling? To understand the hydrological processes, to estimate the individual hydrological components, to generate scenarios with respect to land use change and climate change, to manage water resources for the benefit of mankind, river management, groundwater management, and analysis of the extreme events like heavy rainfall, flood conditions, or drought conditions. But now the problem comes with the variations. India is a large country, and several type of variations is there in the climatic parameters, like spatial variation if we see in Rajasthan, there is an average annual rainfall is about 120 mm, and in Meghalaya average annual rainfall is around 12,000 mm. So can a single model or can a single methodology or single algorithm work for the two different kind of varied system? No. So the hydrological processes for the low rainfall areas or arid areas is totally different than the humid areas and the heavy rainfall areas. The same way seasonal variation is there. We have 4 type of seasons. So generally we get precipitation in the rainy season, which accounts for the 70 to 90% of the average annual rainfall. And then annual variations are there. Sometimes drought years will be there, sometimes wet years will be there. So there is a large variability in terms of the spatial variation, seasonal variation, annual variation, in terms of input parameter itself. So if our model having input parameter which is so diverse in nature, so it is very difficult to set up a suitable model or a single model for all type of conditions. So we'll see now the how many types of models are there and what type of inputs will be there and which model is to be chosen for which purpose. So I'm going to tell you about the type of hydrological models now. There are various types of hydrological model. Let us start with the lumped model. We have very simplified model. Lumped model is the model which doesn't account for the spatial distribution of input variables. Suppose your watershed is having area of around 1000 kilometers square. For a single parameter like curve number if you are taking, so spatial distribution of curve number is not taken care by this lumped model. Lumped model takes care of the single parameter and uniformly distributed the same parameter over the whole watershed. So spatial distribution is not there. And the other type of model is distributed model, which take care of the spatial variability of input variables, typically by dividing the watershed into equally sized grid cells that we call as a raster formats. So there are two different subcategories are there: semi-distributed modeling and distributed modeling. Distributed models is totally distributed. Each and every parameter is spatially varied, and in semi-distributed modeling, some part of model is behaving like a lumped model, and the some part is behaving like a distributed model. That means few parameters are distributed, spatially distributed in nature, and few parameters are fixed with the spatial.
Sorry to interrupt, sir. There is one, you have to again click on present now because someone has actually created a disturbance between.
Okay, so from which slide I should start?
Like from the last slide only. Just you have to click on present now.
Okay.
On people you can go. The people you can go and you can click on present. Your name will be there.
Is it coming now?
Not yet. Now it's starting to come.
Okay, so I just
Yes,
explained that there are several type of hydrological models. One of the model is lumped model, which is not taking care of the spatial distribution of the input variables or parameters. That means it doesn't represent, these parameters doesn't represent the heterogeneity in vegetation, soil or other watershed characteristics. And the other type of model we have is the distributed model, in which the spatial variability of input variables. The distributed model explicitly accounts for spatial variability of input variables. That means the input parameters are spatially distributed in nature. There is a subcategory of this type of model that, hello, am I audible? Hello.
Yes, sir, you are audible.
Yes, sir, you are
Yes, sir,
audible.
you are audible.
Yeah, some person's noise is coming in between. Okay. Okay, not an issue. So, semi-distributed modeling model are having uh, two different factors. Like some part of model is behaving like a lumped model, and the other part of the model is behaving like a distributed model. That means the few parameters we can represent spatially varied, variable in nature, or spatially distributed in nature, and some few parameters we can represent a fixed for a
Sir, again, there is
area.
a same problem. Someone has clicked on presentation, so you have to do the same again.
Okay. So, for example, semi-distributed models, I have put some examples like SWAT model, soil water and assessment tool, is a purely semi-distributed model. Some part of the input parameters are fixed in nature, and some part we can specially distributed in the nature. HMS is also one of the semi-distributed model. And for example, the fully distributed model, the example is WIC, variable infiltration capacity model. This is the fully distributed in nature. Each and every parameter of this model can be spatially varied and distributed in nature. So this is about the categories of the spatially distribution of the model. So now, if we go for the hydrological processes wise distribution, so we have empirical models, physical models. So empirical models are based on the simplified, experimentally derived relationship such as linear regression. So when you put the rainfall runoff regression equations, if we that equation from the observed data we can apply in for the future input data sets, that will be the empirical approach to estimate the runoff for the future events. In the same way, physical models are there. Physical models are derived from the equation describing the conservation of mass, momentum, and energy. This is more accurate than the empirical model, because empirical model, the relationships are made for some other area, for some other input parameters, or some other data sets. But that is not necessary that can be fitted in the some other data set. But physical models represents the physical processes lying behind the hydrology. So this is more accurate than the empirical model. And for the duration wise, we have two categories: event model and continuous model. So event based model, that takes care of the event only. Like HMS is the example of event based hydrological model. HMS we can't set for the whole year. for whole year hydrological modeling setup, we cannot do with the using of HMS. But yes, SWAT will take care of the continuity of the model for the whole year, or there is no limitation of the number of years in the SWAT model. So there are several advantages and disadvantages of different models. So I have just laid down some criteria for the selection of hydrological model. Which model has to be selected for which purpose? It totally depends on the objective, on your area, for what area you are setting the hydrological model, for what objective you are setting up the hydrological model. So different criteria are there. I have laid out four main criteria. There are several criteria. So like we talk about the space distribution. So I just talked about the space distribution. There are three categories: lumped model, semi-distributed model, hydrological model. These are the evaluation parameters. So the ranking is low, medium, and high. This is the ranking for the complexity. When you set up the lumped model, the complexity is very low because single parameter you have to give, and the spatial distribution is not there, heterogeneity is not there. So it is very simple model. So complexity ranking is very low. In the same way, distributed model complexity ranking is very high because each and every parameter is totally fully distributed spatially. Uh, eh, as per the criteria of the hydrological processes, there are empirical approaches, conceptual approaches, and physical approaches like vegetation layer, single layer, multiple layer, two layer. So as you increase the vegetation number of layers, the complexity of the model increases. So now I'll just show you some few widely globally used hydrological model and what are these the advantages and disadvantages of these model. So like we talk about the HEC HMS. HEC HMS I already told that it is an event based model. Out of these four model HEC HMS, SWAT, Mike, SHE, and WIC. This is the only model which takes care of the event based model. We can't go more than the event based. The event can be of any duration, 1 day, 3 day, or weekly duration. That doesn't matter, but it is suitable only for the events, not for the long term hydrological simulation. And other three models, SWAT model, Mike, Tree, and WIC, they can take care of the long term hydrological simulations. Like if runoff estimation, we see the hydrological processes by distribution, HHMS and SWAT is the empirical model. However, the MIC and WIC is the physically based model. That means the physical equation of conservation mass, momentum, and energy are incorporated in the algorithm of the MIC and WIC model. So these are the different uh, selection criteria I have given, and in the last column, output has been shown like flow hydrographs, annual yield, percolation, ET, interflow, overland flow, surface flow. So more or less the output parameters are same, but the underlying processes of the hydrological modeling are different, and climatic regime are different for different models. Now come to the geospatial inputs. Every model should require some type of inputs. Without any input, model can't generate the output. So basically, hydrological models should have three different categories of the inputs: topographical inputs, meteorological input, and land surface parameters. Topographical inputs like elevation, digital elevation model, and their derivatives such as slope, aspect, flow direction, flow accumulation, drainage network. So for to derive these elevation derivatives, only one thing is required, that is the elevation details that you can easily get from the digital elevation model. Then the next meteorological inputs: rainfall, temperature, radiation, relative humidity, wind speed, and wind direction. Many meteorological parameters are there. Then come to the land surface parameters. Land surface parameters are such as land use, land cover, soil moisture, land surface temperature, albedo, ET, snow cover area, snow water equivalent. These are the broadly used input parameters for to set up the hydrological model. Now I'll just brief about what is remote sensing and what is GIS. Now then next I'll come to that how these parameters can be retrieved with the help of remote sensing and GIS, and how to integrate these parameters into the hydrological modeling by giving the example of HEC HMS hydrological model. So let us just brief definition of the remote sensing. What is remote sensing? Remote sensing is the science, or is it is a, basically an art to obtain the information without even touching the object. So we have our eyes, nose, ears. So these three remote sensors everybody is having. Eyes can see the object and analyze the object without even touching them. Nose can smell the thing without even touching the object. So it is the art of obtaining the information about an object, area, or phenomena through the analysis of data acquired by a device that is not in contact with the object, area, or phenomena under the investigation. So remote sensing basically is for the analysis, for the capturing of the uh, data information, and GIS is not the data capturing mechanism or data capturing science or data capturing art. It is the analysis system. It is a system for capturing, not the data capturing. Data captured by the remote sensing, it will just integrate the captured data, storing, checking, integrating, manipulating, analyzing, and displaying data which are spatially referenced to the Earth. That's why it is called as a geographical information system. Everything it relates to the geography of Earth, spatially referenced to the Earth. This is normally considered to involve a spatially referenced computer database and appropriate application software. So remote sensing is a separate thing, independent field. GIS is an independent field. With remote sensing data, we can analyze with the help of the GIS software. Now, role of remote sensing and GIS in estimating catchment characteristic. Like in picture one, typical this watershed has been shown. Like the outlet is there, so the area draining to a common outlet is known as the watershed. So it is surrounded by a boundary, watershed boundary, and watershed divides. River mouth is there, groundwater aquifer is there. So in the second picture, I have seen the catchment as seen is the remote sensing image. How the watershed is actually looking as the in the remote sensing image. So in the second image, you can you identify where your watershed divide is there, where is the outlet location is there. It is very difficult to analyze in a purely remote sensing, raw remote sensing image. So that's why we need to integrate these remote sensing images with the help of GIS. So GIS and remote sensing play an important role in providing the base data and suitable platform for creating, analyzing, and modeling such geospatial data for the given catchments. So in the third picture, you have seen that by using the GIS platform, we have plugged several images. We have integrated hydro points, outlet, drainage lines, catchments, elevation, land use. So to generate a real world situation to analyze in detail the hydrological processes. So to add on these facilities, the Indian imaging systems are there. It started in back 1979 with the Bhaskara satellite and goes on till now. So we have just progressed in terms of resolution, in terms of spatial resolution, in terms of temporal resolution, radiometry we have increased. So data capturing techniques are evolving day to day. So we have started IRS 1A, 1B with the special resolution of 72.5 meters. Now Partisat 3 has been launched, which gives the special resolution of 0.25. That means 25 centimeters. So even from the height of 600, 700 kilometers of the satellite platform, so we can see the object of at least 25 centimeter over the Earth. So that is the improvements. We have improved 1 kilometer to 0.8 meter or 0.25 resolution, and global remote sensing data can give you the global coverage, and with the very less temporal resolution, even every day you can get the remote sensing image with different satellite, and the remote sensing satellites are obviously application specific. For different applications, we have different type of satellites. For water resources purposes, what are the satellites? I will just take in the later part of my lecture. So in previous slides, I have just shown you the geospatial inputs that are required for the hydrological modeling. So these are the inputs I have shown you in the previous slide, and in the red color, I have shown the which satellite is to be used for the downloading of the data. For the remote sensing application in the water sources, you we need not to generate any type of derivative or any kind of specified input. Everything is available over the internet. You just have to download. Like elevation raw data, you don't require actually. Already DEM has been created by the different satellite agencies. You just have to download the SRT like SRTM DM, ESTA DM is there, Carto DM is there. DM digital elevation model is already created by the raw elevation data. So there are different type of levels of the remote sensing data, level 1, level 2, level 3. So this I am talking about the level 4 products. So finally products are there. You just have to download these products. So for elevation, SRTM, Ester, Cartodium, several type of satellite sensors are there. Rainfall we can estimate, we can retrieve from the TRMM, Tropical Rainfall Measurement Mission, TPC, INSET or Kalpana. NSEP NCAR will give you the temperature. AIRS gives the radiation data. Relative humidity we can get by the INSET series or AIRS sensors. Land use, land cover, there are several satellite, multispectral satellite, Landsat, Spot, IARS. MODIS also gives you the land use, land cover data by using the multispectral bands. Soil moisture through AMSRE, SMOS, SMAP, different satellite sensors are there. And MODIS is having 36 spectral bands, so it will give more parameter like land surface temperature, albedo, evapotranspiration, snow cover area, snow water equivalent. So these are the broadly used geospatial inputs. Now I'll talk about the geospatial database creation for a hydrological modeling. So the catchments, geographical features which are important for hydrological perspective can be easily estimated using GIS. So some of the GIS tools are like ArcGIS, HGeoHMS. ArcGIS is a proprietary software, GIS software for the analysis or storing the remote sensing data and for analyzing. Then ArcHydro for catchment delineation and morphometric analysis. ILWIS, Integrated Land and Water Information System. It is for hydro processing tools. And GRASS or QGIS. Like other two, the first and second is based on the ArcGIS, that is the proprietary software. Licensing is required. If somebody is not having any license or proprietary software, then the fourth option is QGIS. QGIS is having all type of add-ons, all type of integration is there. So anybody can use it. It is freely available. So first option I just said that the ArcGIS had GeoHMS. So
Sir,
GeoHMS,
sorry
yes.
to interrupt. Actually, again, that someone has created a problem. Please pin that presentation again.
Okay. Okay, so first option I was talking about the ArcGIS Head GeoHMS. Head GeoH is a GIS integration for the hydrological modeling system. So it is basically used for the geodatabase creation for a HMS system. HMS is the main standalone hydrological modeling system, and to add on the geospatial database creation, like input database creation for this model, the Head GeoHMS plugin has been used. In the same way, ArcHydro plugin is there, but ArcHydro is just for the hydro processing of the watershed. It will not create you the geospatial formats which HMS has to be utilized. So this is the flowchart of the geodatabase creation for a catchment using the Head GeoHMS. So raw GIS, raw remote sensing formats has to be taken, then GIS processing has to be done. The GIS pre-processed special hydrological database has to be given to Head GeoHMS, then hydrological processing has to be taken care by the Head GeoHMS, then it will extract the different parameters required for the HMS modeling like grid format, SSG, HRAP, graded hydrological data, HMS inputs, watershed and river characteristics, and this will give you the this type of format which is readily to be used in the HMS model. So this is the snapshot of the HMS details. Like several options are there: terrain processing, so in which telling of the sinks, flow direction, accumulation, stream networking, catchment, polygon processing, drainage line processing. All the things can be done by just clicking. You just need to give the input, the digital elevation model. Then basin processing can be done with the help of the software. Then basin characteristic has to be given, like basin slope, centroidal elevation. So different type of methods are there to select. Different type of algorithms are there. So it depends on the user which type of algorithm he or she wants to imply. That several options are there. Then finally hydrological parameter details. So there we have to select the hydraulic processes, routing processes, kinematic web parameters, and the other things. Just we have to give the processes. No data has been required for the GeoHMS. Then it will just give the outputs in the format of HMS. Then these outputs will act as the input for the HMS softwares. So the very first input requirement is the digital elevation model that can be downloaded from any website. Like I told that SRTM is there, which gives you 30-meter DM, 90-meter DM. Caster gives you 30-meter DM. Cartosat DEM is the Indian satellite, which can give you the 10-meter resolution of the digital elevation model. So, but I'll just talk about the data issues in DEM for catchment geodatabase creation. What are the errors or data issues are there? It is not like that you just have to download the data and just put into the model and create some output. It will give some output, but you just need to be sure that your output is accurate and satisfying your objectives and your needs. So some data issues are there which you need to be addressed beforehand. Like first data issue is low relief terrain. Low relief terrain, that means the local depressions are there. Suppose a stream is coming and the DM is created in 10 years back. So the part of that region elevation is different with the current situation. So maybe a local depression or local relief pixel has been occurred, which will create the restriction to your natural flowing drainage path. So these address to be issued by superimposing the published stream. If you have the stream network beforehand, or you can just digitize the stream network with the topo sheet, with the help of topo sheet, and just superimpose these type of stream or watershed boundaries which is available readily. So to address these kind of issues, man-made structures are there. So it doesn't. It is not necessary that the remote sensing data captures the man-made structure, because the remote sensing data capturing date you don't know. If you go to the metadata, you can just look when the data is being captured. If it is before the creation of the man-made structure, then you have to manually edit that type of structure. That type of structure is there, and manually editing of the field has to be done. Some data is having missing elevation data because of the some cloud cover is there or some canopy hindrance is there. So the backscatter or reflectance has not been captured by the sensor. So some part of your area can have the missing elevation data that can be filled by the use of the interpolation techniques. Subsidence and impacts is the same as the low relief terrain. Subsurface flow like volcanic soils, limestone formation, and others lead to drainage pattern that a terrain cannot reproduce. So that manually has to be corrected. Now I'll again come to the hydrological modeling part. So this I already told you that hydrological simulation with the help of HMS is comprising of the two parts. First is the standalone GeoHMS part. Second is the standalone HMS part. So in GeoHMS, DEM is the input, digital elevation model for the hydro processing, for the watershed delineation, and soil and land use land cover map for the generation of curve number grid for the estimation of runoff by using the SCS curve number methods. So hydro processing has to be done, then watershed delineation, then generation of curve number grid, finally hydrological processing. So these parameters will go to the HMS. Then the method has to be selected, like loss rate, transformation methods, base flow separation methods, routing methods, and reservoir routing methods. Finally, hydrological simulation and validation of the simulated discharge at different outlets. You can do sub-basin outlet or basin outlet or the reach level also. You can just compare your results. So HMS mainly is having 5 basic components which are essential for any hydrological modeling studies. That are basin model, meteorological model. So basin model just captures the hydrology or catchment behaviors. Meteorological model describes the meteorological properties, rainfall, temperature, humidity, solar radiation, wind speed, and etc. Time series data, it describes and stores the time series data. Like if you have rating curve for your study watershed, so you can just give the rating curve or unit hydro curve as a paired data. And control specification is describes the time duration for the hydrological study. All these data is to be created from component menu of the HMS. So, now HMS is having theoretical assumption. That assumption is made that hydrologic processes can be represented by the model parameter which reflect average condition within a sub area. That means it is talking about the semi distribution of the model type. So model parameter which reflects the average conditions. So it is not the wholly distributed. This is the theoretical assumptions. And the model parameter represents temporal as well the spatial averages. And main limitation is that it is the event based model. We can't set up this kind of hydrological model for the long term hydrological simulations, and it is a systematically represented by the interconnected group of Hackman model components. So by skipping one type of method, we can't go to the next step. So these are the interconnected. The input of one, the output of one method has to go as an input to the other. So this is the limitation of this model. Now I'll just talk about the model components in detail. Like loss methods are there, so several subcategories are there to select: initial and constant, Hack exponential, SCS curve number method, Holtans method, green amp method. For the surface runoff estimation, unit hydrograph, class hydrograph, sliders, SCS, kinematic wave. These are the methods available in the GHMS platform. Then routing method, flood routing methods are
Arpit sir, sorry to interrupt you. Again,
Same.
someone has, you have to do the same.
okay. So for flood routing, it's coming.
It's
Hello,
working now,
coming?
sir.
So flood routing methods are like Muskingum, Modified Pulse, kinematic wave. These type of different type of flood routing methods are available. So I'll just tell you what type of the input parameters are required to set up this kind of hydrological model. Like if we talk about the loss method, like how precipitation uh, loss has to be taken care, like in terms of interception or in terms of runoff. So several methods are there, like initial and constant. Like you have heard about the pi index or W index. So this is the calculation for the rainfall loss, initial loss. So initial rainfall loss, we have to give constant loss, impervious area percentage. These are the input parameters. For Hack exponential method, starting loss, initial accumulated rain loss, rate of change of loss, exponent of loss, impervious area requirement is there. For SCS converge method, very minimum input, that land use map, HSG hydrological soil group map, and by the integration of land use and hydrological soil group, we can just generate the top number table. So this is the method which requires very minimum input. Holtans method required equivalent infiltration rate, growth index, impervious area, exponent of moisture storage. And green amp method needs the initial loss, volumetric soil moisture deficit, wetting substance. So not all the methods can be taken care by the remote sensing data, but yes, more or less we can just provide the main database, main geospatial input databases to just provide the add-on for the model. Like SES curve number method is fully can be controlled by the remote sensing geospatial database inputs. Like, but if we talk about the Holtan's method, so moisture storage or exponent of moisture storage, these kind of terms cannot be retrieved with the help of remote sensing. So that the user has to decide which method has to be chosen, which kind of parameters, input parameters are available with the user, then only you have to select the input method. Like this is just a pictorial example of the initial and loss method, how the infiltration has to be initially fixed and the constant over the other period of the hydrological modeling time. This is the using the loss method. Rainfall axis has to be computed using the phi index. This is the rainfall curve number estimation, SCS curve number method, in which the very minimum input is required. So we have a type of land use land cover map which can be retrieved with the help of remote sensing and GIS. Antecedent moisture condition based on 5-day total antecedent rainfall. Rainfall parameter can be retrieved with the help of TRMM or CPC. So 5-day antecedent, that means the previous sum of the previous 5-day rainfall events, which can be easily retrieved with the help of remote sensing. So based on the AMC conditions, there are 3 AMC conditions, 1, 2 and 3, depending on the amount of 5-day antecedent rainfall condition. The AMC condition has to be decided. Finally, hydrological soil group has to be prepared with the integration of land use map and soil map. So different type of hydrological soil groups are there, like A, B, C, D. D represents the highest curve number, A represents the lowest curve number out of that particular land use. That means that D is having higher runoff potential and lower infiltration rate. A type of hydrological soil group is having low runoff potential, that means it generates low runoff compared to B type of soil hydrological group, and A is having higher infiltration potential, that means the more amount of water in comparison with the D hydrological soil group goes for the infiltration. In the same way, Holtan's method, it needs parameter like growth index. Growth index can be easily retrieved with the use of remote sensing. Plant growth index. The other parameter cannot be retrieved with the help of remote sensing. For that, you need to go to the field survey. Greenert method, the parameter required are hydraulic conductivity, porosity, and wetting front friction. So these are all about the loss methods. Now, if we talk about the surface runoff methods, the unit hydrograph method is there. Input parameter required hydrograph ordinates, class hydrograph, time area curve, time of concentration, storage constants are required parameters. Snyder's unit hydrograph, which is for the engaged basin. So time lag and peak coefficients is required. SCS method, the same way, SCS time lag runoff curve number is required. Kinematic wave, overland, flow length, slope, and runoff coefficient is the input parameter. So this is the just an example I have shown for the unit hydrograph, Clark hydrograph. The time of concentration storage coefficient has to be decided. Snyder's unit hydrograph, standard length time storage coefficients. So different parameters are there like CT, L, LCA, coefficient representing the basin slope and storage can be retrieved easily with the help of remote sensing. Length of main channel from the basin outlet, length of main channel to point near to the centroidal. This can be easily identified with the help of GIS. SCS method, this I'll explain later. Kinematic wave, overland, slope, length, slope, runoff coefficient. Only this runoff coefficient parameter has to be assumed. Otherwise, flow length and slope can be calculated in the GIS. Then come to the flood routing method, Muslimum method, Muslimum pulse method. So the parameter required are like number of sub-reaches, coefficient of storage, weighing factor, channel length and channel slope of the Muslimum modified pulse, channel length and channel slope methods are there. Now, these are all the four type of parameters have to be decided. Methods are to be decided like loss method, transformation methods, surface runoff methods, and the flood routing method. Now, I'll just let you know that what type of remote sensing component in which method, in form of which type of input parameter we can give the in the model. So, like loss method, different four type of methods were there, but remote sensing input directly can be given to the SES curve number method like land use map, soil texture map, and a whole task method, growth index that is dependent on the NDVI normalized different vegetation index can be retrieved using the remote sensing. In surface runoff method, the same SCS curve number method has to be implied and land use and HSC map can be given. This previous slide has shown the remote sensing component. That means the derived parameter to be directly downloaded from the remote sensing agency. And the GIS component, that means in GIS platform you have to analyze the data, remote sensing data to derive this product like digital elevation model, drainage map, that are DM derivatives, loss method, curve number. The land use and HSG map can be directly given by the remote sensing, but curve number has to be generated in GIS platform by the integration of these two. Surface runoff method, class method, time area curve can be generated using GIS. SCS curve number method already spoken. Flood routing method, so Muskingum method, length of channel and travel time can be easily calculated with the help of GIS components. So this is all about the HMS hydrological model. It's geospatial inputs. What type of inputs are there? What type of data can be readily available for the setup of the hydrological model and GIS component. Now I'll just show you the case study which we have done for the flood modeling for the Mahanadi river basin with the help of the same hydrological modeling system. So this is the flow chart of the methodology. So GTOPO 30 DM we have used for the hydro processing as a basic input parameter. Now for the land use land cover map we have used FAO, Food and Agriculture Organization Global Land Cover data, GLC data for the land use land cover, and the FAO the same data set has been used. Organization data has been used for the soil map FAO MM5. Then for the hydro processing, drainage map, watershed map delineation has to be done. Then finally the geospatial data integration for hydrological simulation. That means the integration of the hydrological this watershed hydro processing data with the land use and the soil map along with the meteorological data. Meteorological data also we have used the remote sensing based rainfall data which has downloaded by the CPC Central Processing Center. Then data formatting with respect to hydrological model, because different satellites give the data in different type of formats. So you have to bring all the data set to a single format, to a single projection system. So data formatting has to be done. Then finally surface runoff computation, flood routing and discharge estimates has to be done. And final result were compared with the observed data sets. So physical parameters generated from the DEM like fill sinks, filling of the sinks, that means the addressing the low relief drainage issues. Then flow direction, accumulation, stream definition, stream segmentation, watershed delineation, watershed polygon processing, stream segmentation, and other things has been done using the GeoHMS hydro processing tool. So this is the raw DEM of GTOPO 30. And this is the hydro processing has been done to generate the flow direction map, flow accumulation map, stream grid map. For stream flow accumulation, stream thresholding definition, the number of cells has to be required to give the how many means which pixel has to be defined as the part of stream. So the largest drainage area you can define or the number of cells you can define. So that means that if you are your watershed is having crores of the pixels, so every pixel is having contribution of certain pixels. Like I have defined 2012. So each and every pixel it will just look for the flow accumulation. If flow accumulation value is found above than 2012, then it will be located as the stream pixel. So that will be a part of stream. Otherwise, the overland flow processes has been applied for that pixel. So the same watershed polygon processing has been done. Finally, the watershed delineation has been done with the use of with the output as watershed polygon map river shape files. Finally, the basin boundary with the drainage line has occurred. Uh, this is only the input parameter. The only input parameter has been used is the digital elevation model (DEM) as a geospatial input. And when you define the outlet, it will give you the basin boundary with all the drainage network files. So HGeoHMS is having option to edit also this type of watershed delineation processes. Like if you need to correct some of the basins, if your drainage network is not coming in some part of the river basin. So, for example, I have shown the encircle part. I have merged these two sub watershed into a single watershed. So this type of correction or basin altering watershed network drainage network altering you can do with the. Finally, the centroidal flow path calculation has been done. There are two type of methods available. So the basic input parameter is drainage map and watershed map. Gauge location has to be identified. To be done, river length calculations, river slope calculation, longest flow path calculation, centroidal flow path calculation has to be done to have the estimation of centroidal flow path. In the same way, longest flow path estimation has been also done. For basin centroid, three methods are available. In this project, we just use the flow path method, which computes the centroid as the center of the longest flow path within the sub-basin. So this is the centroidal flow path map by the use of flow path method. And the same way, longest flow path computation has to be done. And finally, routing parameters have to be defined. Only the parameters have to be defined that can be changed in the standalone HMS version also. This is just for the geospatial database creation. So to link the stream with the channel parameters. So bottom width, you have to define bottom width. You can just easily calculate with the use of Google Earth software. Just zoom at your stream level and just measure the bottom width. Side slopes can be measured. Manning reference coefficient that you have to assume or survey over the field. So these are the parameters we have defined, like bottom width, side slope, Manning reference coefficient with different watershed ID. So this is the integration of all the parameters in GIS platform. Manually, it is very difficult to integrate these parameters in a single place. Then finally, curve number grid generation has to be taken care by the combination of soil and land use maps. This is the land use map of the Mahanadi basin, and different land use having different soil hydrological group. So finally, the integration has to be done with the soil map, which is having the distribution of soil hydrological group. So that table has to be given with the weightage of the hydrological soil group of the soil types. Finally, curve number integration, union of the soil and land use map can be prepared. So the curve number values, average value is calculated for each unique polygon. So this is a semi-distributed model. So we have used the averaging of the pixels. Otherwise, it will be very difficult to analyze the curve number for every pixel. So this is the curve number grid map of the Mahanadi basin after the resampling. Finally, worksheet for computation of time of travel according to the TR55 methodology that has been defined by the United States Department of Agriculture. That computation sheet is generated automatically. You just need to export this sheet to your MS Excel and check the parameters available. All the fields are already filled up by the hydrological modeling system, GIS platform, GeoHMS. Only the 2-year, the seventh row, 2-year 24-hour rainfall parameter has to be defined because it is not given as the geospatial inputs. So by defining this 24 hours 2-year maximum rainfall, the watershed time of travel has been computed. Again, save the data and back to the GeoHMS. So it will reflect the changed database or edited database to the geospatial databases. Now export everything. You need to export everything to HMS platform. So reach autonym, basin autonym, as per the terminologies used in HMS, we need to export them. Then this type of files, export message has been occurred: basin file, HMS file, meteorological file, map file, model files, DSS. If you are having any meteorological parameter in DSS format, control specification, and gauge networks. Now, meteorological input we have not given in as a part of GeoHMS, geospatial inputs. So for meteorological data processing, we have downloaded the meteorological rainfall data from the CPC, precipitation data, georeference these data to the or region, subsetting, layer stacking, and finally zonal status has to be done. Then this data can be exported into Excel sheet and we can provide manually or in form of DSS also. It can be. Hello. Hello, Dr. Mahesh, am I audible? Hello.
Yes, sir.
Am I audible?
Yes, sir, you are.
Some noise is coming. Okay, so this is PPC Global Precipitation System, which has been downloaded. Then subsetting has to be done, georeferencing has to be done, and then subsetting for the our study area has to be taken place. Then precipitation we have just exported in form of DSS values, and in HMS platform we can see the pictograph. Then finally, our geospatial inputs along with the meteorological inputs are ready for the hydrological modeling. Now only simulation has to be done. So this is the GeoHMS first view. When HMS first view, when you get all the exported data from the GeoHMS and incorporate it in the standalone HMS model. HMS is not having any integration with the GIS or remote sensing platform or software. It is a standalone platform. Only the GeoHMS has been used to provide the geodatabase for the HMS model. Otherwise, if you want to set up HMS model as a standalone without any use of GeoHMS model, you can always set up. But only the thing is, you have to define each and every parameter which is specially distributed in nature. You have to provide manually. So in GeoHMS, the manual task has been taken care. So this is the HMS model first view. The Mahanadi basin model has been set up. All the signage is there, where the sink is there, junction is there, outlet is there. So if we click each and every signage, you can get the data. What data is there in that sub-basin or in that outlet or in that reach parameters what we have defined, it is already incorporated in this model setup. Now we have to again select the loss method. So what we have selected in the GeoHMS is for the temporary selection of the methods. Now here we have to select finally which method has to be used. So based on constant of the data availability, and we have to imply more the remote sensing data. So we have just choose the SES curve number method for the loss method, in which the input parameter is land use and curve number method is there. Curve number is there. Then for transformations, again we have used SES curve number method, unit hydrograph method, or class unit hydrograph method. For flow routing, the remote sensing based input is only input parameter we can imply in the Muskingum method, in which the side slope bottom width is required. So this type of methods has been selected. and data we can edit what we have given in the GeoHMS. Otherwise, we can just carry forward this data to the HMS platform. So this type of table has been generated, and we can see by the clicking of any reach of or any sub-basin thing. These are the parameters are there. Base flow method has to be identified, whether we want to choose constant monthly or variable slope method is there. So there are 4 different type of methods are there for the base flow separations. We have used constant monthly. Final simulation has been done. So in control specification, we have to choose the duration for the simulation. So although it is a event-based method, we have tried to see what are the results for the long-term simulations also. So in first simulation, we have chosen the control specification as 1st January 2003 to 31st January 2003. And meteorological parameter, we have taken the graded rainfall data of CPC, which is available at 0.1 degree, that means the 11 kilometer graded rainfall data. And in simulation 2, we have taken CPC based sub-basin centroid average daily rainfall for the year 2003, and some field gauge data is available from June to September. So simulation 1 is having purely remote sensing based inputs, and simulation 2 is having remote sensing based inputs plus field rainfall data. So when we compare the outputs of these 2 type of simulations, so obviously simulation 2 gives you the better results because the observed gauge data is available with us. So we have assimilate this data into the hydrological model. Otherwise, in simulation 1 also the hydrograph is very well captured, and the simulations has been matching with the average monthly simulations values has been matching with the observed values. So this type of simulation you can just carry it out with the help of GeoHMS and HMS platform. Now I will show you some of the quick case study what we have done with the help of hydrological modeling, remote sensing using the remote sensing based inputs. Like everybody knows that 2013 Kedarnath disaster took place, in which lakhs of lives we have lost. So what we have done with the 17 June, the disaster has taken place, and within 4 hours of the disaster, we have just set up the model, hydrological model, and see what type of damage is there, what type of which are the probable area getting inundated in the further downstream level like Haridwar and Rishikesh area. So the travel time is more than our simulation time. So in the same day we have simulated and just pass on the flood inundated area information to the local authorities in the Rishikesh and Haridwar district. So just to take the preventive measures. So this is 3 types of DM we have taken: Cartosat DM, Ester DM, SRTM, just to select which type of DM is suitable for that type of terrain. So terrain is very complex in that Kedarnath Mandakini watershed. The river name is Mandakini, so we just call as the Mandakini watershed. So the terrain is very complex, which varies from the 1500 meter to 6924 meter. So the spatial variation of the elevation values is very high. So after the hydro processing for the Kedarnath, for all the type of DM, drainage network delineation, catchment delineation, finally we have selected the Ester DM, which is of resolution of 30 meter. Finally, the travel time, basin lag has been calculated, the area demarcated, and slope you can see 132% slope is there, 104% slope is there. So the hydrology is very complex and no observed data is available. So in a very short time, we have generated the flood hydrograph for the Mandakini River Basin. Rainfall data, just we have taken the real-time TRMM rainfall data for the simulations. So our hydrograph is roughly matching with the published data later on what we have compared. So this type of study also we can do to generate the results and to mitigate or to take the preventive measures in view of any disasters. And this is the another example for the Solani watershed in which only the SCS curve number method has been implied without any model, this GIS platform. So this is the methodological approach, remote sensing and GIS approach. So LULC method, LULC map and soil map has been taken for the creation of the hydrological soil group. Finally, curve number has been generated and slope curve number has to be corrected according to the slope. So different algorithms, different equations are available. So finally, the calculation of S, it is the surface retention, has to be done, and finally runoff estimation has to be done without any software, this GIS software. So this type of inputs directly can be downloaded. This is the expression of runoff. Q is equal to P minus 0.2S whole square divided by P plus 0.8S, where P is the rainfall. Rainfall, we can give the gauge data, or you can assume something if you want to generate the scenarios of different kind of rainfall runoff. Then S is the potential maximum retention, that is the function of curve number, and curve number is a function of integration of land use and soil map. So these are the material, the very minimum material which can be used for the hydrological model is precipitation and satellite data for generation of land use, land cover, and DM easily can be downloaded, soil map can be downloaded. So these are the things we have done. These are the maps has been prepared in between of the setting of the model. This is the soil. Some field work we have done just to see hydrological soil group. This is the soil map and land use land cover map, and this is the percentage cover. Slope adjustment curve number, after the integration of LULC and soil map, the curve number estimation has to be done, and then some slope correction has to be required, because if curve number 75 represent the percentage of runoff at some place, it doesn't it is not necessary that the same percentage of runoff will be there at some another place which is having the 75% curve number. So slope adjustment has to be taken care by different three methods, which is given by Williams, Shapley Williams and Huang. So these are type of conversion formula has been implied. Rainfall maps are there. So different rainfall maps are there, different seasonal analysis, annual analysis has been taken care. So to generate the rainfall runoff scenarios. So without any objective related to the disaster, this modeling, so we just try to see the scenario generation for the Solani watershed. How rainfall is changing with the how we have changed the rainfall, and the output, the runoff scenario has been changed, and which approach has to be chosen for this type of watershed and this type of methods. So this type of time series plot of rainfall and estimated runoff can be easily generated. These are the surface runoff values. So surface runoff component was calculated on a daily basis of monsoon season for all watershed, and then average value of surface runoff of 70.82 mm with annual precipitation of 6.2 mm is found. So these type of analysis can be done, and I'll just show you some complexity of the hilly terrain. These are the pictures of the flood affected areas of Uttarakhand. So how remote sensing and GIS is very useful in terms of management of the water resources. So these are the highly complex topography of the Uttarakhand area, which is getting flood affected, like flood prone areas of Uttarakhand as seen in the remote sensing image and 3D data. This is the Alaknanda river from Hanuman Chitti to Govind Ghat, which is getting affected in year 2013. So this is the remote sensing data, and if we merge with the 3D data, so this is the raw remote sensing data or raw terrain data. When we overlay the infrastructure or the demographic layer, so you can see the whole city is there at the mouth of the danger. So at the bank of the river, whole this Ghansali city is located. So if flood comes over this area, so whole city has to be vacated. So this type of scenario generation you can do. You can also use the hand tool. I'll just explain in later slide for the estimation of flood inundation area. So this is the Srinagar area in Uttarakhand. This is the Mandakini river up to Rudraprayag and overlaying with the demography data. This is topography based flood prone area for northwest Himalaya. We can do using the hand tool height above nearest drainage. So just we have to give the water level as an input. Like for any river, if water level rises by 5 meters, what will be my inundated area? So this type of experimental studies anybody can do. This is very simple methodology. So if we talk about any river, any small river, water level is all the current water level is known, then just increase that water level by 5 meter or 2 meter or 10 meter. Then in GIS, just overlay that water level in the topographical map and see how much area is getting inundated and what area is vulnerable, what type of land use also is getting affected. That can be seen by overlaying the land use map also. This type of studies can be quickly done with the help of remote sensing and GIS. And another case study I'll show you for the Brahmaputra river basin. This is the largest river basin. So we have set up the hydrological modeling. So this is the DEM sub-basins land use land cover map, curve number map has been generated with the help of GIS. So this is the overall and the integration of Sarva type of water level maps. This is already I have talked about GeoHMS hydrological modeling setup. What unique thing we have done here is that integration of the altimeters of the satellite, which can give you the water level data directly. So water level can be directly retrieved with the help of remote sensing. No discharge estimation is required. No modeling setup is required. Remote sensing data will give you the water level, river water level. So that ultimately raised water level we have retrieved with the use of remote sensing data, and just this water level data we have assimilated into the hydrological model. What water level data hydrological model is giving, so that we have already corrected with the help of altimeter based water level. So our hydrological model is further more calibrated for the simulation. Finally, the simulation has been done and then it is compared with the CWC observed data. So this is the very recent advancement in the water resources, that altimeters. So some of the future satellites is also there, like CARIN, CAB and microwave based altimeters is there in SWOT satellite, soil, water and ocean topographic mission. Sentinel is there. So these are some Indian Earth observation missions in near future what we have planned. So ResearchSat 3, OceanSat 3, which is having KU band spectrometer, which can be used for the retrieval of snow water equivalent. ResearchSat 2R is there, list 3, list 4. So in this the 2.5 meter spatial resolution is there. GeoHR, geographical higher resolution imager is there, which will give you the 50 meter resolution. And the main thing is that, unique thing is that this satellite is geostationary. So every time you can get the data. Cartosat 3 is there, which provides 30 centimeter resolution. These are the Indian Earth observation missions, and further I'll just tell about the few global satellite missions which are very useful for the water resources studies, like GRACE 1 and GRACE 2. These are the gravity recovery and climatic experimental satellites launched in 2002, and further follow-on mission has been launched in 2018. These are the two identical spacecraft flying about 220 kilometers apart in a polar orbit. So it is utilized for to map the Earth's gravity field. So by measurement of the Earth's gravity field, we can estimate the total terrestrial water storage, because as per the theory, gravitational theory, the mass is more, so gravitation pull is more, so gravity is more. So it is assumed that where the Earth's gravity is more, or is gravity field is more, so there the Earth's mass is more, and that the Earth mass is because of the terrestrial water storage. So on these assumptions, the satellite retrieval processes works to estimate the terrestrial water storage (TWS). MODIS satellite MODIS is a payload scientific instruments launched in 1999. So there are two sensors are there, Terra and Aqua. The total 36 spectral bands are there in a wide range of 0.54 micrometer to 14.4 micrometer. That means the multispectral, infrared, and thermal band. So it has have several applications in the water resources. So land use land cover map can be generated. Land surface temperature, albedo, ET also can be estimated with the help of thermal bands. So several applications it will serve the purpose. So these are the atmospheric products and land surface products are available with the MODIS satellite. Cryospheric and oceanic parameters is also there. Megatropic, it is the Indo-French mission to study the water cycle in the tropical atmosphere in the context of climate change. It was launched in 2011 and it has 4 sensors: Madras, Sapphire, Scarab, and Rosa. So for water resources, Madras sensor was there. It is not now in the working condition now. So it was for the microwave analysis and detection of rain. So we can easily retrieve the rainfall or precipitation amount out of this kind of sensors. OceanSat 2 is there, in which this KU band spectrometer is there. It is very active microwave device to determine ocean water level, ocean surface water level, and wind products, and also the retrieval of snow water equivalent can be done. Saral is the satellite with Argos and Altica. Just I told you that altimeters. So Saral is the altimeter satellite. Carb and altimeter is there to retrieve the ocean surface topography and the river water level also. Inside 3D is the meteorological data relay and satellite aided service for the rescue satellite. It has 3 payloads: meteorological, data relay transponders, and satellite aided. It will provide the storm warnings systems to protect life and property and to monitor the Earth's surface and carry out oceanic observations. SBAS was launched in 2009 to retrieve the soil moisture and ocean salinity. Soil moisture data also we can retrieve through the remote sensing satellite and then assimilate in the hydrological model for further calibration, because ET and other calculation has to be carried out on basis of soil moisture data. If soil moisture is accurate, then further ET may be more accurate in the models. So this is all about my lecture today. If anybody is having any queries, just please.
Thank you so much, Dr. Arpit Chokse. And first of all, I would like to say thank you so much for accepting our invitation, for giving us very informative lecture. And one more thing, I would like to say that it was a very wide explanation of the GIS and remote sensing, and that can be used in hydrological modeling. So in simple words, I would say that I actually saying in the introduction that GIS and remote sensing, these are actually the tools that can be helpful for any of the person, like who those who are working on field, those who are working on site. So they can actually, without going to the site, without going to the field, they can retrieve the data, they can analyze the data, and they can get the idea without going to the site. So that is actually very good thing that I was talking about. We need to give some solution to the society. So that is actually the tools that you can get flood modeling, you can get the inundation model, you can manage, or you can do the disaster management, you can predict the disaster. So these are the several applications that has been explained very well by Arpit sir, and he has done a great job, and he has actually explained all the things very well. So I would like to say thank you so much once again.
Thank
And
you, Dr. Mahesh, for inviting me in this workshop.
now I would like to take some questions from the chat box, and so the first question actually is raised by Kanwar Amitos, that he's saying that can you explain or elaborate the physical model?
In chat box, I can read the question.
Yes, sir, you can read the question.
यूट्यूब का क्वेश्चन पहले उसका चैट वाला सब
Where is that?
Yes, sir. So they are he asking about that physical model. How can you explain the physical model that two models we were talking about? I think.
Okay, physical models are actually the models which describes the physics behind the hydrological processes, like in terms of the conservation of mass, conservation of momentum, and conservation of energy. Like Saint Venant equation, you have heard about for the hydraulic engineering. So this is the physical equations, and if the model has to be prepared or synthesized in terms of the expression of these type of physical equations, then that model will be more accurate for the any application, and this is further called as the physical models, which has the physical meaning of the processes.
Okay, sir, and I can also take some questions from YouTube link. Actually, some of the people are watching on live streaming on YouTube. So there is one question that can you please explain the different tools in GIS and ArcGIS for hydrological modeling?
Like I shown in my PPT, Arc Hydro tool is there for simple special analysis tool is there for hydrological watershed delineation, but this total watershed delineation cannot be done with the help of ArcGIS standalone. Okay, so further some plugin has to be introduced like Arc Hydro and Hack GeoHMS. What I have shown in Hack GeoHMS is a freely available plugin for the ArcGIS. You can just install. If you have ArcGIS licensed version, you can install this plugin and use it for hydrological modeling or database creations.
Okay, sir, and there are some Meera Mohan, she is asking about this GIS remote sensing will help you to flood forecasting or not?
Yes, surely it will help you for flood forecasting. Only the remaining parameters are fixed, like your land use is for a, if suppose for a particular watershed you are working and you have set up the model beforehand. So land use, soil map, and other routing methods and other things are fixed. Only you have to change the different type of rainfall scenarios, because in future when flood event will be there, you are not sure what type of rainfall intensity will be there, what type of rainfall frequency will be there. So different type of scenarios you can generate with the help of different rainfall scenarios beforehand, and you can prepare the output in terms of flood scenarios that can be used for the flood forecasting measures.
Okay, sir, I'm taking one last question from the YouTube link. One Nidhi, and she is asking about, is there any openly available software for hydrological model?
Yeah, Hack GeoHMS is freely available. If you are not having the licensed version of proprietary ArcGIS software, you can use the QGIS, or SWAT model is there, soil and water assessment tool. So SWAT model is free, and the plugin is also working with the ArcGIS and with the QGIS. So QSWAT you can download QSWAT. That is the SWAT plugin with the QGIS.
Okay, sir. So I think now you can also take some question from the chat box. That is on Google Meet. Some Rishi Thakur, he's asking about QGIS software comes with different application inbuilt it. Which one should be used? Saga GIS, QGIS desktop?
I'm not getting the question.
He is asking about there are different versions of QGIS. Which one should be used for hydrological modeling? There is one written Saga GIS, QGIS desktop.
Okay. QGIS is a GIS software. You have to install the plugin for the hydrological modeling or hydrological data analysis. So there are several type of plugins available. So depending on the objective, if you are want to generate the hydrological type of geodatabase creation or hydraulic modeling, hydraulic routing techniques you have to apply. So different type of plugins are available with the QGIS. You have to install depending on your objective. But QGIS is just a GIS platform. It's not a hydrological software.
And it is also freely available to everyone.
Yeah, it is freely available.
Okay, so there is one
this
question:
is
how can
open
I
source
get?
also. Yes. Sir.
Yes, sir. Thank you. Now there is one question: how can I get 3 meter data elevation? I think DEM he is asking about.
3 meter.
3 meter DEM. That means he was maybe asking about that pixel size for 3 meter.
Okay, so he or she may be talking about the Cartosat data. Cartosat data we have Cartosat 2 series is having a special resolution of 2.5 meter, but that is not for the general public use. That is for the defense purpose, and we will supply you that publicly available data is of special resolution of 10 meter. If you go for the Indian data, so you can't go below 10 meter.
Okay, sir. And now there is one similar question. To the two people have asked the same question, like how we can plot sub-watershed boundaries of a small canal in QGIS.
Can you repeat the question?
Maybe he is asking about the how we will plot sub-watershed boundaries of a small canal in QGIS. Maybe he is want to digitize that small canal.
No, but he's asking about the sub-watershed boundary and the canal in the same line. So it is
I think they are
totally
both different words, I think.
two different things are there.
Yes. So we can talk about small canals, how we can digitize them, because it requires very less
Okay, digitization.
high resolution we will be required.
There are two techniques. Automatic digitization is there, manual digitization is there. So if we are having any topo sheet or any previous map available, just geo-reference that map and take into the QGIS platform. And there are techniques, manual digitization tools are there. We just manually digitize them. Or automatic digitization also can be done. If you have black and white type of image, so make all the canal area as a black or white, whatever it is, and just tell the software some tools are there to highlight these or to prepare a shape file, vector shape file out of this type of color, like black or white. So polygons can be prepared. So this will be the automatic digitization technique.
There is one doubt asking what is the difference between contour and curve map.
Contour is related to the elevation values and curve number is related to the land use and soil. So these are two different parameters, two different independent parameters.
Okay, sir. One Rijupoli, he is asking about can we measure ocean salinity
Yes.
using satellite?
Yeah, ocean salinity can be measured. One sensor is there, soil moisture and ocean salinity. A small satellite sensor is there with the help of. So I am working in the hydrological modeling domain. So marine and atmospheric department is there, which is taking care of the ocean salinity and oceanic studies. So I am not much sure about the technical details of that salinity, but yes, it can be measured with the help of SMOS.
Okay, sir. I think now we have taken so many questions and you have given answers of all the questions. Now time is over, so we cannot take all the questions. If anyone will feel any doubt or any problems, they can send an email to Arpit sir on his email ID. I think it is written at the end of the slide. That is arpit@iirs.gov.in. So here you can write your questions. And now I would like to say thank you so much to our speaker, Dr. Arpit Chokse. He has explained all the things in a very good manner. So the second part, I would like to say that we are going to take 1 hour break. Okay, so after that, we will have a new eminent speaker from IIT Roorkee, Professor R.D. Garg. Please keep your presence in that particular session also. So now I would like to say thank you everyone, all the participants and Dr. Arpit Chokse. We will keep in touch after this session. So we also need some details from your side. Thank you, sir, and thank you, everyone. Please stay tuned for the next section that will be starting at 2:30.
Thank you, Arpit sir. Nice presentation, sir.
Thank you, thank you.
This is Mahanadi from Vignan Bharati Institute of Technology, Hyderabad, sir. Very nice presentation, sir. If it is possible for your side, please send your PPT to all the participants, sir.
Yeah, just give me an email. I will revert it back.
Yes, sir. I will post in the comment box, sir. Chat box, sir.
You can send the email, sir. You can send the email
Because
to
there are
Dr.
so many
Chokse.
thousands of chat is there, so it is very difficult to find that particular chat. So just give me an email.
Yeah, thank you, sir. Why? Because I am doing PhD in my same area, sir. That's why I am asking, sir. With your permission, I will send mail, sir. Thank you, sir.
Yeah, sure.
So everyone, please take your lunch. Then we will meet at 2:30. So before 2:30, you can join 5 minutes before the session because we also need to do some modification in the audio and all those things. So please stay tuned. Okay, sir. Thank you.
Sir, Dr. Mahesh, sir. Same link, sir.
I Hello everyone. Actually, there is some technical error, so we are going to solve it very soon. I think Sir has joined now. Very good afternoon, sir.
Very good afternoon to Professor Rajiv and all the participants of the workshop.
Good afternoon, sir. This is Dr. Mahesh, and this is your warm welcome to the third session. And I know before starting, I would like to introduce yourself because I know there is a lot of things to say, but I will introduce in very few sentences because there are a lot to say about you. So I would like to introduce our eminent speaker, Professor R.D. Garg, and he is a faculty in Civil Engineering Department, Indian Institute of Technology, Roorkee, and he has also served as a Vice Chancellor of Uttarakhand Technical University, Dehradun. And he completed.
I think you have mixed the CV. There are two Gargs, there are two professors in Civil Engineering Department. He is some other person, P.K. Garg, who has served as Vice Chancellor.
Sorry, sir. Actually, I have taken.
I can speak about me. Basically, I did my bachelor's in 89, master's in 92 from Roorkee University. Now it is IIT Roorkee. After that, I joined ISRO, Indian Space Research Organization at Dehradun. And after that, I completed my PhD from like a sandwich PhD program from IIT Roorkee as well as ITC, the Netherlands. and then I switched over to IIT Roorkee in 2007. And presently, I am serving as a professor in the civil engineering department. We have the geomatics engineering group, so it is a part of civil engineering department. Basically, we are a small group having only 5 faculty, and we have been working in remote sensing, GIS, GPS, image processing, UAV, LIDAR, etc., etc. I hope you all are aware that there are so many things which can be done in geomatics engineering right now. All right.
Thank you so much, sir. And I really apologize because there was some misunderstanding about the name.
Yeah, yeah, okay.
And now, actually, I would like to request you to please share your PPT so we can start the presentation. Then I am asking you to please, I am handing over to you, sir.
Yeah, wait, present my entire screen.
There you will see, sir, whenever you will move the mouse, sir, you will get present now option at the.
Yeah. I'm looking for that only, present now. And are you people looking my screen?
Yes, sir. We are now able to see the screen also.
Okay. So again, good afternoon to all the participants of this workshop. If the voice breaks as well as the connection breaks, all of you, please make me aware of that. And I will like to go for number of questions. Like it will be good if you people are having questions, then we can have substantial time for the question. Although I am not able to see any of you because now the screen is covered by only my presentation. All right. So all of you, please make me aware in case there is any problem about it. All right. So I will like to share my views on a very relevant topic, that is a global navigational satellite and augmentation systems. Basically, it has got two parts. One part is GPS, which is a part, which is a global navigation satellite system, GNSS, and there is one more SBAS, that is satellite based augmentation system. So I have tried to cover the two topics in this single session. So first of all, what is a GPS? And we want to know that what are the characteristics. So in a short line, if we want to define the GPS, it is a very precise positioning system, because as the word, this acronym says, global positioning system. This system is basically for the positioning. And why global? Because it works in the entire globe. And now, when we just say about the characteristics of the GPS, it has got so many characteristics. That's why it has become so popular nowadays. First of all, it is free of cost. As you can say, you need not pay anything for the service. Only thing is you have to pay for the equipment. Then it is precise. It gives you a quite reasonable data, a quite precise data. It is reliable. The data it is giving, it is not like your normal mobile phone that you don't know whether the call will be connected or not. The data is reliable. Whatever information is given, it gives all weather. It can work even in bad weather. As you know that number of equipments, they are not able to work in the bad weather, just like rain, etc. But GPS can give you information. It can give you data at that time. There is a slight, like there are chances of slight error. It means your data, your coordinates may not be very precise, but still you will get a very good type of data even in a poor weather. Then it is any time as well as anywhere. You can use it in 24 hours day. As anywhere means any part of the globe. In fact, scientifically we say it works on all the latitudes and longitudes. Unlimited user capacity is again one more important thing which comes nowadays in the networking systems, because like your GPS receiver is only receiving the data from the satellite. It is not transmitting any data. That's why there is no bandwidth limitation. and you can connect unlimited users along with the GPS as such. So, and we say that when we say anywhere, there are few places where it may not work, just like the valleys near high-rise building, etc. If your equipment is not able to capture the signals from the satellite, then obviously it will have problem in giving you the information. Now, on the basis of these characteristics, if we try to define GPS, GPS can be defined as satellite navigation system designed to provide instantaneous position. Why this letter is in a different color? Because in surveying also, we all are civil engineers, or maybe you are from some other specialization, but in surveying, there is no other technique which gives you the instantaneous accurate position just like GPS. All other things like leveling, theodolite survey, total station, it will take some time in giving you your position, but GPS can give you a standalone, independent, instantaneous position to you. And it gives you the velocity as well as the time information, and again almost anywhere on the globe at any time in anywhere. And as we discussed earlier, GNSS, Global Navigation Satellite System, and GPS are nowadays used as the same term, because GNSS is a scientific term and GPS is a commonly used term nowadays. Now, there are various GPS systems which are designed and executed by different countries. As you can say, Navistar is by USA. It is the most common GPS system available nowadays for a common user, and Navistar is the longest working system also. So after that, there is a GLONASS by Russia, Galileo by European Corporation, BDS or BDAO Navigational Satellite System by China, QZSS Quasi-Zenith Satellite System by Japan, and again there is IRNSS Indian Regional Navigation Satellite System by India. So these are various type of GPS system available around the globe. Now we would like to see something more about this system. Navistar, it is an acronym of Navigation, Satellite, Timing and Ranging System, and it is the most commonly used system, as I have told earlier. It is under US Department of Defense. Normally GPS started with the military use only, and slowly the governments allowed the civilians also to use it, but still the major part of the frequency is encrypted, which is only in the control of military. So you see that it is a military as well as civilian system. The worldwide navigation and positioning resource for military as well as civil use for 24 hours. Obviously, even for military or civilian use, it is working for 24 hours. It is not like military will use it for 6 hours and civilians will use it for 18 hours. It is not like that. One more system, GLONASS. It is by Russia, as we already discussed. It is a global navigation satellite system developed by Russia long back, and when it was USSR. It has got 24 satellites in 3 orbital planes at 64.8 degree inclined to the equator. The orbital height is 19,100 kilometers. You may be wondering why I have not given you for Navistar, but Navistar data I will give you in more details. So it is using two frequency basically. It has got L1 band and L2 band, and it is 16 or 2.5625 megahertz to 1615. Why they all are using two frequencies? Because one is given to civilians, other is kept for the army, etc. So for some time this GLONASS was non-operational in between, but now Russia has again sent more satellites and now it has become operational. ISRO is having plans to collaborate with Russia over the GLONASS series of satellites. One more is Galileo. Galileo is a private GPS system which is owned by several countries of Europe. So it is Europe's global navigation system. And why there is a need of a private system? Because it has been seen that other GPS systems are under the control of military. of respective countries. That's why these countries have got the power to stop the transmission of GPS or stop the usage of GPS in the war time. So at a particular time, a country may be in war, so they will stop the signal. So a person cannot use it even for the civilian use. That's why it has been conceptualized that there should be a system, or there should be a GPS system which can work even in the war time or even in emergency for the common people. That's why Galileo has been conceptualized. So it says guaranteed availability of service under all but the most extreme circumstances. So it is suitable for applications where safety is crucial, such as air and ground transportation. So there are few satellites in the orbit from Galileo, but important thing is it is still not operational yet. So they have planned with 27 operational and 3 active spares. Orbital planes are 3. Inclination of the orbit is also given, and orbital radius is also like, but it is not fully operational yet. What is the advantage of Galileo? You can see in these 5 points. First of all, it is open access. It is free to air. It is for the mass market, simple positioning. But if you want a commercial output from it, commercial output means it is having high accuracy. The signal will be encrypted. You have to take the license for that, but the service will be guaranteed. They say that they have got one more type of facility, that is safety of life in case of any distress. Suppose you want to just go for searching of any party, etc., whatsoever this case may be, then it will give you the facility. So it has got the integrity as well as authentication of the signal. STAR is one of the important application, that is search and rescue. It can give you near real-time precise data, and the return link facility is also there. It means if a person is using the Galileo handset, they can also give the return signal to the control center so that their location can be traced as such. So this STAR is a very good facility which Galileo will provide. And last is the public regulated, encrypted integrity and continuous availability, because no government control is there over the Galileo. Now coming to another one, BIDAO. BIDAO, also named as Compass, is a Chinese system. So initial system will provide the regional coverage. It has got a target of 2016 to become the global. Look, they have designed their GPS constellation in 2 ways. First of all, they have made the regional coverage operational. What is the meaning of regional coverage? Now the system will be working over China, over their country as well as the surroundings. But if they want to make it global, they have to send more number of satellites, which is not complete yet. So you can say that they have to launch total 35 number of satellites, but they have not launched it. Out of that, there are 5 geo orbit, it means geostationary or this satellites, and 30 MEO means mid-earth orbit satellites are there. 6 orbital planes, orbital inclination and radius of orbit is given over here. And it will give you the level of service in 2 forms. First of all, public service for the civilian use and the licensed military service, and obviously the military service will only be available for the Chinese military. Now, Quasi-Zenit satellite system by Japan. It has got 3 satellites. It is again a regional system. So the satellites in the highly elliptical orbit. The advantage of this orbit is the satellite will dwell for more than 12 hours within the 70-degree elevation. So it means that it will be more available. The satellite will be available in the Earth atmosphere for connectivity. So it appears almost overhead. Hence the term quasi-zenith has been used for this. Regional coverage aimed at precise time control and the GPS augmentation, and not a standalone positioning system. It works with some other system like Navistar or GLONASS. Now, coming to the Indian initiative. So it is IRNSS, Indian Regional Navigation Satellite System, and recently it has been renamed officially as NAVIC, Navigation with Indian Constellation. So first of all, it has been planned in India, planned by India as has been given to you. And why there is a use of the Indian system? There is a news report that during the Kargil war, India, like Indian military, they could not access the full signals of the GPS in order to locate their troops and other type of works. That's why after that, India has planned to launch their own satellites, but they have gone only with the regional system. IRNS is the regional system. They have got 3 geostationary, 4 geosynchronous satellites with a 24-hour time period. And regional coverage is there only for the Indian subcontinent as well as some of the surroundings. You can see that about 1500 to 2000 kilometers beyond Indian range, and the transmission is S-band. But the accuracy of this IRNSS, whatever has been achieved, is quite good. Accuracy is within 2 meters. That's why IRNSS is nowadays, it is operational. It is now used by a number of services, and it will provide two level of service. First is the standard positioning mode, standard positioning service (SPS) to all the users, and the restricted service (RS), which is an encrypted service only for the authorized users. So also government has made IRNSS mandatory for all the commercial vehicles in India from 2019, so that any control center can monitor the movement of all the commercial vehicles like trucks and buses, etc. So it is useful for the safety of the consignment as well as safety of the passengers also. Just comparison, a table has been given over here, which gives you the comparison of all the global navigation satellite system. So different type of systems, as we have discussed, the countries which operate and own them, number of satellites. You see that different systems have designed their orbits in different manner. That's why number of satellites required are also different. So altitude are also designed in different manner as well as as per the requirements of the orbital parameters. So like Navistar is 20,200 kilometer altitude with 6 orbital planes, GLONASS, Galileo, etc. They all are having different one. And the coverage global regional, you see that the initial one, Navistar, GLONASS and Galileo are global. VDAO is regional oblique global. QZSS is regional. IRNSS is regional. So these all are the comparative evaluation of these services. Now, very important thing over here, why at all we use the GPS? You can see that GPS can provide the positioning accuracies which are ranging from 100 meters, 5 to 10 meter, 1 to 2 meter, few centimeter, few meter. Why at all we have got this large range? First of all, you see that if we want to have a very poor accuracy, or like you can say that an error of few meter will not affect my purpose, my application, then I can go for the navigational or handheld receiver. Navigational is a scientific word. Handheld means I can use it just by putting in my hand. That's why it is also called as handheld. Now, just assume that how can I make an error of 100 meter and what will be the use of that? Nowadays, you are using the GPS in your cars also. Suppose the car is moving at a speed of 80 kilometer per hour and you are using the GPS. What will be your purpose? At that speed, you are not willing to take the coordinates, but you simply want to know whether you have reached your destination, whether you have reached Jalandhar, whether you have reached NIT or you are closer to NIT gate, etc., etc. So at that high speed, even an error of 50 to 100 meter will be okay for you. That's why we use this system. All right. Next, I am walking with a GPS in my hand. So since I am walking, I am not allowing the GPS to take the proper signal. It may give you an error of 5 to 10 meters. Okay, I just want to have an idea about the NIT Jalandhar campus. I don't want to map it. Okay, it's all right again. 5 to 10 meters is again okay. Now, if I stand at a particular place, at a particular location for a few minutes, maybe for 2 to 5 minutes, then the data will stabilize and the GPS accuracy will increase. At that time, I will get an accuracy of 1 to 2 meter. Now you see that equipment is same. I can get an accuracy of 100 meter to 1 meter out of it just on the basis of time of observation. So if I give time to observe, then I may get 1 to 2 meter accuracy. Now, if I want to go for further improvement from few centimeters to few millimeters, the same navigational GPS receiver will not work. And now I have to go for the another receiver, which is known as geodetic GPS receiver. Geodetic GPS receiver is working on some other mode. I can just share at this place. Otherwise, we have got a full slide for that. Navigational receiver, it receives the code-based data. Code-based data. Geodetic receiver, it receives the carrier, it receives the phase-based data. It receives the phase, so that's why it can give you very high accuracy. Obviously, the higher accuracies involve a greater infrastructure and thus a greater cost. Just on the, you can say, approximate terms, navigational GPS receiver, it costs about 5,000 rupees to 1 lakh rupees. Well, it means it has got so many things over there, but it starts from 5,000 rupees. Geodetic GPS receiver, it starts from about 4 lakh rupees. A good quality geodetic receiver is very costly. It starts from about 4 lakh rupees. That's why it depends on your accuracy, your application, that which GPS receiver you want to take. Now, coming to a very important thing, that is a GPS segments. GPS can be divided into 3 segments, and these segments help the working on GPS. So first one is space segment. As you can see here, it has got the satellite constellation. It means that all the satellites which are giving us the signal, they come in the space segment. Second segment is the ground control segment. When the satellites are moving in the sky, there must be some control mechanism. There must be some monitoring mechanism for that. So that is done by this control segment. And then there is a user segment where we all exist. All of us exist because without a user, you launch 100 satellites, there is no user of that facility, then what is the purpose of that? That's why user segment is also very important. We all exist in this one who use the GPS. Now, coming to the space segment, and please note that all these characteristics are for Navstar. Just we have compiled the characteristics of Navstar. You can make a similar this detail for the others also if you want. Although Navstar is the most common one, that's why I have made the slide for Navstar. So space segment means you have got a satellite constellation which is moving in the sky. It is moving at a height of 20,200 kilometers and 55-degree inclination. It means that the orbit, can you see this orbit? This is one orbit, it is inclined at 55 degree from the equator, and there are 24 satellites in all, which are divided in 6 orbital planes. So 24 divided by 6, it means that 4 satellites are there in each plane. So you can see here, and why they are having 24 satellites? In fact, they require only 21 satellites, but they are also having the 3 active spare. It means if any satellite goes out of order, if it is not working, then still you have got some spare satellite which can take its place, and your system will be proper functioning. So this we have seen, altitude is 20,100 kilometer, orbital period is 12 hours, and you know that satellites are arranged in 6 circular orbit, and why they do for all this type of arrangement? The basic purpose is to have at least 4 satellites visible. Why 4 satellites? That we will see later. At least 4 satellites visible above the horizon, anywhere on the earth at any time of the day. That is very important thing. They have made these satellites arranged in 6 circular orbits so that minimum 4 satellites are available at a particular location to give the signal. In fact, nowadays more than 4 satellites are visible, so that is always a better thing. So, but minimum 4 we want. And GPS satellites, they transmit signal at a frequency L1 and L2 are the name. So these are the two frequencies which are allocated to L1 and L2, and they are also known as P code and CA code precisely. P is the precision code, which is available only to the military, only to the US Army, and CA is the post acquisition code, which is available to almost every civilian usage. GPS satellites lifetime is 5 to 7 years. It means if you want to make your system working for longer time, you have to keep on launching the satellites after an interval of 5 to 7 years. And that was the reason we have discussed that GLONASS was not working for some time. It was due to the reason that they could not launch the subsequent satellites to keep it working. That's why for some time it was inoperational. Now they have completed the constellation again, and the GLONASS from Russia is again operational. Alright. Then second segment is the control segment, as we discussed. It consists of 3 entities. Master control station, that is the most important and it is the only one. Monitor stations are so many, and after that ground antennas are there, which are just located at number of places. These are again more than even the monitor station. So you see that the master control station just at USA. So what is a master control station? It controls each and every movement of the GPS satellites. Alright. So the master control station located at Falcon Air Base in Colorado Springs, Colorado. It is responsible for the overall management of the remote monitoring and transmission sites. It provides the accurate GPS ephemeris. What is this GPS ephemeris and how it provides? Basically, you see that there are so many monitoring stations, and we see that the major monitoring stations are located along the equator, because at that location you will have the maximum coverage and visibility of the satellites. All right. So all the satellites which are moving around the globe, they will be monitored by these stations. What are these stations? They are at Hawaii, Ascension Island, Diego Garcia, and the Kwajaleon. So basically, these are monitoring the orbits of the satellite. If any satellite is moving away from the theoretical orbit, the theoretical orbit means the orbit for which it has been planned, then the monitor station, they will record that movement, they will record that variation, and they will send the data to the master control station. Only master control station communicates with the satellite. Because if so many stations, ground stations communicate with them, they communicate with the GPS satellite, there may be confusion. That's why they have got only a single master control station. It communicates with that. And you know that from ground itself, in a satellite, there are some booster motors which can be fired in order to bring back the satellite to the correct orbit. The number of times they apply the correction measures and bring it back to the corrected orbit. In case they are not able to do that, still they record that variation in the orbit. That variation in orbit is given to the users in the form of GPS ephemeris, which will be used for the calculation of coordinates for improving the accuracy. And what is ephemeris? You know about Panchan? It is just like the Panchan. Ancient people, they calculate the movement of stars, planets, etc. And here we are calculating the movement of the GPS satellites. So ephemeris is tabulation of the computed positions, velocities, and derived right accession and declination of GPS satellites at specific times for eventual upload to GPS satellites. All right. Now, this is a control segment which I have already shown you. And just one more thing, we have got some more stations which are marked by this pink color. That is the NGA monitor station. So apart from this main monitor station, nowadays in world, there are some more monitor station which are National Geospatial Intelligence Agency. So these are the, like, this is an independent body which is connected to all the like all the GPS systems. It monitors the movement and it gives the information that okay, whether it is going properly or not. And these the NGM monitoring station data is also used for accurately georeferencing the location of your GPS, because sometimes you want to improve the accuracy. So this data, whatever this NGM monitoring station gives you, they are considered as very accurate. So now we will learn more about the monitoring stations. 6 monitor stations are located at the Falcon Air Base. So like the Colorado Springs has got one master control facility as well as the monitoring station also. So it is at Accession Islands in the Atlantic Ocean, Diego Garcia and Colgelon, and there is one more at the Cape Carnival, Florida. So each of these monitoring stations, they check the exact altitude, position, speed, and overall health of the orbiting satellites. So the control segment, they uses the measurement collected by the monitor station to predict the behavior of each satellite orbit and the clock. The prediction data is uplinked or transmitted to the satellite for transmission back to the users. The control segment also ensures that the GPS satellite orbits and clock remains within the acceptable limit. So one station can track up to 11 satellites at a time. And ground antenna, as we discussed, they monitor and track the satellites from horizon to horizon. What is the meaning of horizon to horizon? Like suppose we are standing at one place, if we see the sky from one end to other end, these are known as horizon. So just like the sun rising from horizon and setting to the other horizon, the GPS satellites also rise from horizon, they set to other horizon. And they also transmit correction information for the individual satellites. Now, coming to the third segment, that is the user segment, most valuable segment for all of us. In user segment, there are so many GPS receivers which a person can use. These GPS receiver can be classified into 2 types. One is the handheld, as we discussed earlier. Handheld is also known as navigational receiver. Why it is handheld? Just like your mobile phone, everything is built in. Everything is built in. What you need? You need antenna, you need display, you need the keyboard, you need battery, you need the radio frequency section for getting the data. Everything is at single device. But this is not very accurate. If you want to record the data very accurately, you have to go with the multi-component GPS receiver, which has got everything as a separate one. Antenna is separate, power supply is separate. Why? Because sometimes you need to take observations for more than 1 day even in order to establish a station. We go for 48 hours observation, 72-hour observation. That's why the power supply should be very robust. CDU, the control and display unit, where you can key in the commands and you can see the output. And this is the radio frequency section, microprocessor, recording device. They all are in multi-component GPS receiver, and multi-component GPS receiver is normally the geodetic receiver. Although geodetic has got no linkage with the multi-component, but normally in order to achieve the accuracy, the geodetic receiver need to be multi-component as such. All right. So first of all, we see the geodetic receiver. You see that this is separate antenna mounted over the tripod. It is the CDU, and the radio frequency part as well as battery is at lower side of the photo, which are not visible to you. This is the one, you see that antenna which is mounted over the tripod, and the radio frequency and other the display and the control unit, battery, etc. They are lying inside this box. Just like the mobile phones, we have got so many companies which are manufacturing the GPS. That's why you will get the variety. These all are the handheld GPS receivers, navigational GPS receivers. Just like mobile, everything is compact. in the single machine. More one, these are from Trimble. So many varieties are there. This is the CDU, control and display unit for a geodetic one, and this side we have for the navigational one. So many GPS receivers just for idea. GPS receiver nowadays are also installed in the car as well as aircraft. You see that it can be the car, this screen or the cockpit of an aircraft. You see that they also have the GPS installed over there because the aircrafts fly at a height of about 8,000 to 12,000 meters, while the GPS satellites fly at a height of 20,200 kilometers. That's why the aeroplanes can take the GPS signals very well. It will be an additional safety feature for aircraft in order to capture the GPS data to know about its location. Although aircrafts before the GPS has come, they have got some other navigational features, but GPS has provided an advantage. It has provided a safety to the aircraft, so all those things. And you say that a person can carry the antenna in the backpack, and these all are the way to do the GPS survey. You can also move at different locations for performing the GPS survey as such. And GPS survey can be installed in the car or at different places. It is basically now coming in different varieties as the embedded GPS system. They are typical GPS receivers which can be used anywhere for interfacing for power, and you can buy it almost over the shelf as such. You see that it is just a chip, and you see that this is a chip which like it is a UNAV chip, very common type of chip, and the cost is less than $1. It is not a very costly one. Cost is very less, and you see that you can even have in the neck band of a dog, in the headband of a livestock. You can wear it just like a watch. So all the information in the collar of the coat, etc. So it means that GPS receivers nowadays are very common. They are so common that everybody is now having GPS in their mobile phones, because what they want a small chip for GPS signal receiving. All other things are provided by the smartphone itself. That's why in our smartphones we have the GPS nowadays. And surveying and mapping using GPS. I hope a few of you are aware of this machine. It is the total station. Total station is for taking the local coordinates. GPS is for taking the global coordinates. In surveying, people are using both the systems all together in order to get more accurate data. And the companies are coming with this integrated system also. The same machine has got a GPS as well as the total station integrated. So the advantage is you can have the accuracy. The total station is more accurate. It gives you millimeter level accuracy. GPS gives you the global coordinate. So combination of that will be very useful for your purpose. And one more small thing. Although the machine, the GPS used here is navigational or handheld, but can you see the screen? You can just see the map over the screen. It means that of late, the companies have started the GIS data collection enabled GPS receiver. It means you go to a particular place, record the coordinate, and that coordinate will directly update the map. That's a very useful feature. And nowadays, number of very good machines are also there. Just like the color display, it is just like a small computer. So wherever you go, you can prepare a map as well as you can update a map. It means that you are in the ground, you can record a new feature directly over the GIS map itself. See that there are so many, it is mostly used for GIS data collection. And this one is used for the recreational purpose, because you simply want to go to the required location. It is the navigation screen. So you want to find out your location, you want to search a location, etc., etc. And nowadays there are so many machines which are available, which give you the GIS capability as well as which give you number of things. Like you can mark the waypoint also, so that the party which comes after you can use those. And even you can mark the waypoint for yourself. if you are going for hiking, while coming back, you can use the same waypoints which you have made. Like you are making the tags on the way. Like if you compare with the older days, people used to mark on the tree or on the rocks that they have crossed this way, etc. Nowadays, you can just mark the GPS waypoints, etc. Now, very important thing, very important slide as such, positioning with the GPS using the three segments. It shows that the three segments will be used all together in order to collect the data. The satellites are there in the sky. They are connected with the user segment. The user is having the GPS receiver, and this is the control segment. The control segment is having the two-way communication with the satellites, but the user segment is having only one-way communication. When the three work all together, it means that you are able to capture the coordinates, you are able to capture the location at a particular place. Now this positioning with the GPS shows that you can work you can work with GPS, you can use GPS in the sky, you can use the GPS on the ground, you can use it over the water also. So even ships can also use nowadays. You see that a ship which is sailing in the ocean, there is no landmark available. So nowadays, GPS navigation is one of the booster for navigation of the ships, etc. And one important thing at this stage, the GPS signal cannot penetrate the ground. It means they cannot work underground. They cannot work in a cave. All right. So they can work only on the ground itself. GPS signals are so weak that they cannot penetrate the building walls also. So you cannot use the GPS inside the building. You have to come out in order to use the GPS. Same thing is here. GPS signals can't penetrate the water body. So they will GPS will not work in the submarine. So they can work only on the ship because a ship can have the access of GPS data. But submarine, since it is moving inside the water, it is not having any access of GPS data. So GPS will not work over there. Now, as we discussed earlier, there are two type of codes or two type of signals which are coming from GPS. So these are the part of satellite broadcast signal, or you can say two forms of clock information. CA or course acquisition code is freely available to the public, and it is a 1023-bit long pseudo-random code, and which is broadcast at this L1 frequency and repeated every millisecond. So just please note this term, repeated every millisecond. It means that the signal repeats itself after every millisecond. While on the other side, the restricted precision code or P code, it is reserved for the military usage, obviously for US military. The P code is a similar code broadcast at L2 frequency 10.23 megahertz, but it repeats only once a week. It means that the signal is so long that its repetition comes only after a week. That's why accuracy increases with the P code. The normal operation, the anti-spoofing mode, the P code is first encrypted into the Y code or PY code, which can only be decrypted by users with a valid key. So, as P code is only used by military, they have got one more code, which is the Y code, and they have given the authority to some users to use the Y code by a decryption. But again, for Y code also, you have to take the special permission. So as we have used that nowadays, there are several GPS frequencies which are in use. So in all, there are five, like you can say, common to use frequency. Otherwise, nowadays GPS is working on number of various type of frequencies. So there is L1 frequency, 1575.42 megahertz. It is mixed of navigation message, course acquisition code, and encrypted PY code. There is second frequency L2, which works on the P code plus a new L2C. There is an offshoot of this L2, which is the L2C frequency, L2C code on the block 2RM. and the newer satellite. These are the various type of satellite blocks, because you see that this Navistar is quite an old system, so they have got upgradation in the satellites also. So that's why it is Block 2RM, and L3 frequency used by the Defense Support Program to signal detection of missile launches, nuclear detonation, and other applications. You see that advanced frequencies are basically being used for the military operations. There is one more L4 frequency. It is being studied for additional correction to be part of the atmosphere that is ionized by the solar radiation. You will see in the GPS error that the GPS signal has got some attenuation. It goes away from the path when it passes through different layers of the atmosphere. So L4 code is used in order to apply that correction, in order to apply the atmospheric correction. And then L5 frequency, it is to be used as a civilian safety of light signal. So internationally protected range of the aeronautical navigation. The first satellite using this signal is launched in 2008. So L5 is basically for the rescue type of operations. Now, we have come to the most important slide of this presentation, that is positioning with GPS. So, as we discussed, that we require a minimum of 4 satellites in order to go for our 3D position. So, why 4? Let us see why 4. So, you see that in the sky we have got 4 satellites, and the location, the instantaneous location of those satellites are marked as X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3, and X4, Y4, Z4. And this is the unknown point where the user is standing with the GPS receiver, and its coordinate can be assumed as small x, small y, small z. This R1, R2, R3, R4 are the ranges. It means the distance between the unknown position and the satellite. Please note that this R1 is the range. Why it is not the distance? Because this has been measured on the basis of time of travel of the signal. How much time the signal takes to travel from the satellite to the ground station. That's why it is R1. You see that. You know the simple coordinate geometry where the equation for the distance between the 2 points can be written like this. So R1, which is the range 1 between the first satellite and the unknown point, is R1 is equal to the square root of x1 minus x whole square, y1 minus y whole square, z1 minus z whole square. Is it okay? So I can make equations for the satellites. As you can see here, I have got total the 3 unknowns, small x, small y, small z, and the 3 equations have been made by me. So as per the law of polynomial, I should be able to solve x, y, and z using the 3 equations. Then why at all we are telling minimum of 4 satellites? The answer is, since this R1 is recorded on the basis of the time of travel of the signal, you please do a simple calculation. Suppose you know that the signal or the speed of light is equal to 3 into 10 to the power 8 meter per second. Alright, so once you have got the velocity multiplied by the timing error. Suppose the timing error is 1 microsecond. So 1 microsecond means 10 to the power minus 6 second. Multiply, velocity multiplied by time error will give you the distance error or range error. How much it is? 3 multiplied by 10 to the power 8 multiplied by 10 to the power minus 6. It is equal to 300 meters. It means that we have to apply correction for this timing, and that correction is applied in the form of the 4th satellite. That's why we take minimum of 4 satellite, and in GPS terminology, it has been told that if you are not applying the correction for the 4th satellite, your entire results may be wrong. That's why it is mandatory to apply the correction. So this is the reason why we require minimum of 4 satellites at a particular location. So we can also understand it like this. Suppose we are 11,000 miles. Like you just take any figure 11,000 miles from the satellite. So if you make a circle, if you make a sphere, you may be somewhere on the sphere. We are somewhere on the sphere. And now, if you, I will just come to those slides. And now, if you just take your location with respect to the two satellites. So now you can create two spheres. Now you can create two spheres. All right. If I take my position with respect to the third satellite, then I have got the three spheres. But please note that intersection of these three spheres will give me 2 points. So in order to find out the accuracy in between 2 points, I require the fourth signal also. Alright, that's why the fourth satellite, the fourth measurement corrects the time discrepancies. So making a timing correction, I go for the fourth satellite. Alright, so this is the purpose why we go for that. And again, now I come back to these slides. What is the positioning? The signal is just shown to go as a straight line, but the actual signal is here. Can you see this slide? So you see that the signals are just like going randomly. That's why it is known as PRN, pseudo random noise code. And this signal, this code is moving from the satellite up to the ground. Now, why it why the signal is used? The signal is used in such a manner so that you recognize the code in the proper form, just like the signal is available at a satellite which is coming from the satellite, and the same signal is available at your receiver also. The receiver identifies the satellite that this satellite will send me this type of signal, and what happens? The signal will come from satellite to the receiver. Receiver generates its own signal, and the variation, the difference between the signal from the satellite and from the receiver is recorded as the time lag, because there is no other means, there is no other physical instrumentation which can find out at what time the signal has started, at what time signal has reached. So this is the PRN code based, pseudo random noise code based system, which is useful for finding out the lag, that like how much time it takes for the signal to travel from the satellite up to the ground. And just we can connect with the previous statement. In the CA code, the signal repeats itself after every millisecond. In the P code, the signal repeats itself after a week. So it means that the CA code has got more chances of error in comparison to the P code. That's why we have got this pseudo range measurement. That's why we call it as a pseudo range, because the distance has not been measured by any physical measurement. It is just the pseudo range measurement. Alright, just we can see the same thing one more time. Measuring the time travel, the time adjustment. You have got the distance from two satellites, satellite 1 and satellite 2. So you can make an arc and you will be able to get the position, but this will be only in the static position. If you want to apply some correction, or suppose we say that there may be a 9 nanosecond error in the satellite 1, there will be 7 nanosecond error in the satellite 2, and please note that accurately it has to be here, but it is over here. How to correct? You can correct it by having the third one. It means that you are somewhere in between this triangle, and where you are exactly, that will be given by the fourth satellite. So that's why I hope it has proved that the correction by the satellite is very important. So measuring the time travel adjustment, you see that now it has come to, all the three arcs have come to a single point. Now, this is a very interesting one. The satellites, when they are located in the sky, they are known as good GDOP, good geometric dilution of precision. So you see that the satellites are just located far from each other. We say some angles are better than others. At the other location, if the angles are the angle of satellites are quite close to each other, we call it as a poor GDOP. Again, poor geometric dilution of precision. It means just getting the signal from the 4 satellites is not sufficient. The satellite has to be located far off in order to improve the accuracy. Sometimes the satellites are located far off, but as we discussed that, suppose you are standing in a valley or standing near the high-rise buildings, so some of the satellites are hidden on the other side of the building or the mountain. So there at that time also the GTOP is good, but due to the poor visibility, you are not able to take the data in this position. Navigational use of GPS nowadays too many. You see that people install the GPS in their cars and they work along there. Navigating the given location, I hope most of us must have used it, maybe on the Google Maps or maybe some other, like even in the mobile also. You know your location where you are, you have to go to the destination. The shortest path would be like this if I connected, but I can't go because there is no road present. That's why I have to go along the road. So this is one of the application of GPS to navigate to the given location. More GPS applications are location-based services (LBS). So it gives you the location-based information, just like there is the restaurant where I want to take the food, where is a vegetarian or non-vegetarian restaurant. Emergency services, where is the police station, where is the petrol station. To track someone, you know that nowadays you can share your GPS signals, so you can track the other vehicle also. Like 2 or 3 vehicles are going all together, you can track their location, where they are going, how far they are, whether they are moving close or not. So you can also develop the smart transportation ITS intelligent transportation system telematics where the GIS as well as the car GPS they works all together, and you will be able to get so many information, automatic vehicle location, AVL for a railroad, etc. can be used. It can be used for the fleet management also. As I discussed that there will be a control station which will monitor the location of all its fleet. So that will be useful for finding the location, where it is going, whether it is going on the correct path or not. It also helps to prevent the overspeeding, because number of times it happens that the driver sleeps or the driver he takes rest in between, and after that, in order to cover the time, he overspeeds that. So these type of fleet management will be very useful for all the things. GPS is also used in the lidar sensor. If few of us are using the lidar sensor, they know that lidar uses the differential GPS signals in order to locate the imagery in a proper manner. The plate tectonics and GPS, the geodetic GPS can take the measurements very accurately up to millimeter level, and the movement of the continental shelf. These are moving a few in a year, so all those movements etc. can be recorded using the GPS. Other applications are in transportation, industry, military, recreation and sports, science, etc. So, like GPS is useful in number of things nowadays. So, we say that GPS is being used for so many applications, but one should be aware about the accuracy of GPS. So, the accuracy of GPS, it depends on some variables, just like time spent on measurement. If you remember earlier we discussed, if you stop at a location for suppose 5 minutes, your accuracy will increase. So it means that if you are going and taking the measurement, there will be less accuracy. But if you stop at a particular place and then take the data, and the information will be more accurate. So this type of GPS measurement is also known as stop and go. It means that you are stopping, taking the measurement, and then you are moving. Design of the receiver, whether it is a geodetic receiver or the handheld receiver, navigational one, post-processing, very important. As we discussed, the precise ephemeris will be broadcast. It will be made available after some period of time. If you really want very good accuracy, then you can download those ephemeris. Ephemeris means the location of the sensors, the location of the satellites So your x1, y1, z1, x2, y2, z2, their values will be revised, their values will be corrected. So your small x, y, z, your unknown position will be calculated to higher accuracy. So relative positions of satellites, often known as DOP, dilution of vision, all these can be taken care in order to improve the accuracy of the GPS. As we discussed earlier, so we have got basically two type of receivers, the code-based as well as the carrier-based. Code-based receivers are used in the navigational system. So here positions are determined from the range estimate, the pseudo range. So we are simply taking the pseudo ranges on the basis of the time of travel of the signal from at least 4 satellites. Pseudo ranges are derived from the time interval from where the signal was sent by the satellite to when the signal arrives by the receiver. Although it is a good method, but it is not very accurate method. That's why the code-based measurement is not very accurate. Next one is the carrier phase-based measurement. So positions are determined by setting one receiver on a point with an established coordinate and then solving for a 3D vector between it and a receiver at an unknown point. It means that you are using the phase. Phase, I hope you all understand. In the wavelength, if the full wavelength is coming to us, that is a full wave. But if a part of the wavelength is coming to us, then it is a phase one. So what we are recording? We are recording the phase of the two equipment. One which is located at the established location. Established location means we know its accurate coordinates, and one is located at the unknown point. So comparing the carrier phase of these two locations, we will be able to get our position at unknown point with very high accuracy. So pseudo ranges are derived by the determination of number of signal wavelength plus any remaining fraction. This remaining fraction means it is less than a full wave, so it is a phase of that wave that separates the satellite and the receiver. So in the code-based receiver, the characteristics are pseudo ranges are determined from time difference calculation. It is smaller, more portable because these are navigational one only, and they have got guaranteed horizontal accuracy less than 15 meter at 95% confidence. Better accuracies they require data correction source that supply data to a differential GPS. So you can achieve, but you have to go for more calculations. The best code-based receiver can achieve sub-meter results under favorable condition because they say that if everything is good, then maybe possible code-based receiver can also give you good output, but it is not certain. The cost is very less, as we discussed, 100 to 10,000. The 10,000 one is having so many other type of feature in between, but basic equipment is coming in $100 only and useful for navigation, mapping, GIS, vehicle tracking, etc. The code-based receiver positioning, each satellite transmit data including the satellite location, exact time the signal was transmitted and the PRN code. And the same PRN code sequence is generated by the receiver. As we discussed, the PRN code generated by the receiver, the PRN code sent by the satellite, they both are compared and then you will be able to get the pseudo range. So the positioning method with the code-based receivers are just like autonomous one, single receiver you are using and you are getting some positioning, you are not worried about it because basically you are doing for navigation purpose. You can use it for differential positioning. Differential positioning I will just cover slightly more detail. So there are two types of differential positioning. In the post-processing one is the real time. I will just cover after it. So this is the figure. Let me cover the carrier phase base, then we will come back. The pseudo ranges are determined from the count of complete wavelengths plus any fractional portion. They can catch from 9 to 12 channels. Receiver must work simultaneously with at least one other carrier phase receiver. But it means that, as we discussed, there should be two receivers which should work at tandem. It means which should work in synchronization. So processing software enables the determination of delta X, delta Y and delta Z. It means that it is the error between the known point and the unknown point. So depending upon the type of receiver and the accuracy requirements, site occupation can be as short short as few seconds or as long as several hours. So it is quite costly, from 10,000 to 40,000. It can provide millimeter level accuracy. It can be used in surveying, mapping, GIS, remote sensing, geofencing, etc. So here also you can see that they have given this positioning methods as static. It means you are simply located at a place for a long time and you are getting accuracy of about half a centimeter. Rapid static, it means that you are not static for longer time, but still for a few minutes you are there. So 0.5 to 1 centimeter accuracy can be there. Kinematic means you are moving, used for collecting measurements while in motion. And the real-time kinematic means used for topographic construction, stakeout, and location survey in the area. I can just show you the figure. Static single point positioning, you are having the equipment at the tripod and taking the data. Static relative positioning, two equipments are there, they both are taking data simultaneously, and later on the correction is shared. Then the kinematic single point positioning, it means that you are having the GPS over a car and it is taking the data while on the go. It is moving as well as taking. Kinematic relative positioning, so here you have got one GPS over the moving vehicle, but another GPS will be at a control station, will be at a known station, which can transmit the correction signal to it. So in this type of positioning, you will be getting more accuracy in comparison to the left one. Now, I come back to the very important concept in GPS, that is the differential positioning or the relative positioning. The same thing as we discussed in other slides. One GPS is located at a known position. Why it is shown as a tower? Because it will not move at all. It is a static one. It will take the recording here itself. So there is a roving receiver. It means that you are moving with your receiver, and what you are doing basically, you are taking the same satellite. That is very important. That's why the relative GPS or differential GPS cannot be performed when the two GPS receivers are quite far. But luckily the distance allowed is about 15 to 20 kilometers. Why? Because we require the same satellites to be recorded at both the places. Now, you see that 4 satellites are giving some data to this known station. Suppose they give the data as 1000, but the accurate coordinate of this point is 1005. It means that there is an error of 5 meters in the particular at the particular instant. If that error is transmitted to this unknown station, it has been observed that it will improve the accuracy of this unknown position a lot. So now we have got 2-3 modes of transmission of data. One is if you have the radio link between the two. Nowadays it has also been performed by the SIM card. Like both the machines have got SIM card, you can transmit the signal using the SIM data transfer. So if you can transmit the signal in the real time, then it is known as a real-time differential GPS. It is also known as RTK, real-time kinematic. But if you don't have any control like this, if you don't have any equipment like this, then what you do, you record the data here in the known station, record the data in the unknown station, come back to the laboratory, just download both the data in a computer and apply the correction. So it means that differential GPS can be applied in real time as well as in non-real time. There is one more thing which we will use in SBAS, satellite-based augmentation system. This particular node station can transmit the correction to a geostationary satellite, and geostationary satellite can transmit the signal to this GPS so that it can record, it can apply the correction in the real time. So this is the concept of SBAS, satellite-based augmentation system. The geostationary satellite has augmented the correction which is to be given to this unknown position. All right. So some errors in the GPS measurements. So various type of errors are satellite clocks, receiver clocks. If there is some missynchronization with that, ephemeris, the first ephemeris which are loaded in the satellite as well as the ephemeris which are available to you after the master control station observe that. Atmospheric error, you see that the signal will not travel in a straight line, it will travel in a zigzag line, it will give you an error. The multi-path error is like that, the signal is again reflected by some other object and then it is received by you. So it is taking a longer path. So again, longer path means your R1 is more. R1 is more means calculation of your coordinate is wrong. And then selective availability, it is just a special type of error which was imposed earlier. It means that you just make the signals of your GPS wrong intentionally so that anybody cannot use it properly. So like it was prevalent in the previous time, but still selective availability can be applied anywhere. That's why one need to be cautious about the accuracy of the signal. You see that the signals which are coming from the atmosphere, they are just having the zigzag type of path. You can also see over there that it is a positional dilution, a precision, signal noise ratio, atmospheric attenuation, multipath. All these things we have discussed. Multipath, one more figure you can see, and signal to noise ratio for the GPS receiver is important. And if you are using a GPS receiver, you can see this type of view. It calculates the signal strength. If the signal to noise ratio is less, then it will just not use the data. Suppose you see that for this particular satellite, the signal is weak, so it will not use that particular satellite for calculation. Now, just I would like to spend some time, although I know that I am getting late. So, satellite-based augmentation system, it is also very important. And why at all we require the augmentation system? Because whatever GPS is providing you, whatever accuracy GPS is providing you, users are not satisfied with that. They wanted a system which can improve the accuracy of that GPS. So for that, satellite-based augmentation system SBAS has been designed. So again, just like the GPS in different countries have got different type of names, they also have different names like VAS, Wide Area Augmentation System in US, Gagan, GPS aided geo-augmentation navigation in India, AGNOS, European Geostationary Navigation Overlay Service in Europe, MSAS, NDGPS, Chinese Budao, India's IRNSS. There are so many augmentation systems available nowadays. So first of all, we will see about VAS. VAS is a collaborative project of FAA, Federal Aviation Administration, and the Department of Transportation. They just wanted the safe landing of their flights. So the aircraft, when it is using the GPS for getting the signal, so it cannot afford any inaccuracy. You see that aircrafts are moving at a very high speed, and due to the less time available for data collection, even if there is an error of 100 meter in the GPS location for the aircraft, there may be an accident. That's why they have designed an augmentation system for that. And I will go with the figure basically, first of all. So it is a vast figure. There are number of wide area reference stations as well as wide area master stations which are located in the entire US. Let us go for this figure. Basically, you know that the GPS satellite, these are the GPS satellites which are in the sky, and they are giving the signal to an aircraft which is either in the flight or which is about to land as such. You see that they are getting the signal from this, and the aircraft, whatever signal it is receiving from the satellites, it is being verified by some reference stations also. What does it mean? It means that whatever signal the aircraft is receiving, same signal is received by the reference stations, and these reference stations will calculate the error. And that error, because the reference station is just like a fixed station, they know their accurate coordinate and they know their instantaneous coordinate. So it is just like the reference field station. They transmit the error to the master station. Master station will give it to the uplink station. Uplink station will give it to the geostationary satellite. And can you see this red line? Geostationary satellite will transmit the corrective signal to the aircraft so that it can correct its own coordinates and the landing, etc., whatever is the usage of that coordinate can be made it safely. And you see that here we have used the symbol of an aircraft, but the same can be used for even the your normal car also. You see that nowadays the car GIS, it gives you an accuracy of few meters, just 1 to 5 meter, and while your car is moving at some speed, it is again due to that augmentation system. So just you see that this BAS is for US. Similar type of system is also made for the local area augmentation. It is for India Gagan. Gagan is a joint project of ISRO and Airport Authority of India. They have got 8 different stations all over India. They use GSAT-4 communication satellites, and master control and uplinking facility have been performed for that. And basic purpose is to improve the air traffic and other civil navigation for these things. This type of augmentation system are also planned by Galileo. Galileo means from European consortium. They have assumed that at a normal this station, they may have an error of 30 to 40 meters with respect to the positioning. But if they are using their own system, AGNOS, you remember that AGNOS is an augmentation system. If they are using an AGNOS, so the error will be in the range of 0 to 5 to 8 meters as such. So they say that for the European community, using the AGNOS will be very useful because they will be able to get the highly accurate signal for them. So this is the AGNOS for all the European countries. They will have good accuracy for that. They also have 6 endless navigation land at sea stations, 2 supporting facilities, mission control centers, etc. So with this, I end my presentation. For some part of that, I have to go slightly fast. I don't know how much clear I am to all of you, but still we can give some time for the question answer if a few of you wish to ask some questions.
Okay, thank you so much, sir. And it's really very detailed information about GPS. Actually, even I am very amazed. Even I was having some doubts. Those you have cleared, and it's very informative, sir. And actually, sir, there are actually a lot of people who have joined through YouTube link. There are around 500 people have joined through YouTube link, and some of them have joined through Google Meet. So actually, sir, there are a lot of questions. So I will take, sir, few questions, and some of them the question I will take from actually from first. I am starting from YouTube link. So one actually student asked about, can the user devices be used as a substitute of ground control in case of disaster, rendering the ground control useless?
No. Yes, what you are telling is correct, that the user devices can be used as control one, but basically you should have a connection with the GPS authority. Like whatever correction you say or whatever correction you have measured, that information should be made available to the main authority who are controlling the GPS, and then if they like, they can use it for just applying the corrective measures for their GPS. Normally, that's why I told you, apart from the GPS owning agency, they have got a number of NGA and other type of stations, the GPS station. It is just like the collaborative agencies in order to improve the GPS accuracy. So normally they share the information with respect to that. But I hope that if any user has found any special type of observation, any discrepancy. So it can be shared with the GPS company, and I hope that they will be able to do something.
Okay, thank you, sir. And I think, sir, there are actually a lot of people, 1,000 faculty from various institutes, and around 1,500 PG students from different institutes, and around 500 research scholars. They have registered for this workshop, and they are some of them have actually sent the question. One question is how we can use GPS in home if GPS signal can't penetrate the building walls.
Yeah, we cannot use, as I told that GPS signals are weak, so they cannot penetrate the walls, as well as you refer to the previous slide for the GPS errors. If you are using it closer to the building, then there will be the multipath error, and multipath error will make your data more inaccurate. So if you are willing to use GPS in your home, the good thing is you come near the balcony or the windows. So from there, you may be able to get some enhanced signal. Like sometimes in the car also, if all the windows are closed, sometimes GPS signals are weak. So you have to open the car windows, and then you get some improved signal. Same thing can be done in the home also. You either go to your roof, or come to balcony, or near the window.
Okay, sir. And there is one question from Kanwar, and he's asking about, sir, can we find the depth of the valley or the ocean or some other water body using GIS remote sensing?
No. Using GIS remote sensing, we can do. Like as I told that in GIS remote sensing, there are so many other type of things. But if we confine ourselves to GPS, alright, GPS cannot give you the depth of water body, because again GPS signals cannot penetrate the water body. Okay, for the depth of valley, it can be done, but the only thing is, in that valley, the valley should not be so narrow such that you are not getting the signals from the 4 satellites minimum. Now, as we discussed that if you are working near the high-rise buildings or a valley, so at least you should have 4 signals available. You should have signals from 4 satellites available. In absence of that, you will not be able to get all those things. And this valley depth means if you are getting XYZ with more accuracy, it will give you the valley depth.
Okay. Sir, there is one more question. How can overcome the errors for the corrective measurements?
Excuse me, can you please repeat it? How can?
Sir, how can overcome the errors for the corrective measurements?
Well, all right.
How to modify the errors like that?
Yeah, I think I have told you about that. First of all, there are few errors which may occur in the GPS data. So first one is the precaution. Second one is the corrective measures. The precaution is you should avoid taking the GPS data near the building, under the tree, or under any structure from where the signal can reflect and come to you. That is one thing. GPS signals are affected by the power lines, by the electricity lines. You try to avoid taking the data under this power line, high tension line, or transformer. That is one more thing. You try to take the data for longer duration. That is one more thing. And again, if you want more accuracy, then you can take the relative point positioning, just like the differential mode. If you want still more accuracy, then you can download the ephemeris data from the company website, apply those, your accuracy will increase. So all these are the steps. It depends what is your application, up to what accuracy you can work, and if you want to go on increasing your accuracy, then all these type of steps you have to take. But please note that all these are not the simple process. These are cumbersome processes. Okay, just for example, you are having a single GPS receiver, you are going and taking the measurement, that is good. Suppose it is giving you accuracy of 1 meter. Then if you are happy with that, it is okay. Suppose you want more accuracy, then you are using the relative point positioning. It means that two GPS receivers are working at the same time. And please note that it will require more infrastructure, more manpower, and more computation. If you are still not happy with that, keep that data with you. After 1 week time, the companies transmit the corrected ephemeris, load those corrected ephemeris, do the computation again, your accuracy will be further better. So again, everything depends on your requirement.
Okay, sir. So there are a lot of questions, but there is one common question I will take. This is the last question, and they are actually asking about what type of signals of GPS is it radio waves, and how it is different from signal used in remote sensing.
Okay, just one thing I can reply with more surety, how it is different with signals from the remote sensing. Please note that in remote sensing also there are two type of remote sensing. One is passive remote sensing, other is active remote sensing. So remote sensing works on several type of wavelength. So these wavelengths are the visible wavelength, near infrared, middle infrared, thermal infrared, microwave. These are the more popular wavelengths of that. So these wavelengths are giving you data about the earth features by interaction. That is one thing. These are the remote sensing signals, which either you take the signals from the earth or you take the signal from the satellite, and these are interacting and you record it back. GPS signals are the radio signals. As we discussed that for connectivity as well as for recording it, they are various type like Gagan uses the S band. Other type of this like GPS etc. I have given you the frequencies also, L1 and L2 frequencies. So these signals they override the electromagnetic signal or the radio wave, because they have to travel at a speed of light, 3 lakh kilometer per second. So these signals are basically the electronic signals which will travel from the satellite to the ground, and they will give you all other data along with that, just such that the time of travel, the satellite identity, as well as ephemeris of the satellite.
Okay. Thank you, sir. Actually, sir, there are a lot of BTech civil engineering students. They are actually asking about what are the application of GPS in civil engineering.
As such, there are so many applications. I have told you, you can update a map. That is the most common application. You have got an old map, like Survey of India topographic sheets are very old. So you have to update a topo sheet. Suppose a new road might have been constructed, a new habitat, a new colony, or maybe a new electric line, power line. And just very this interesting thing, in almost half of India, the power utilities, they are using the GPS and GIS for mapping their power lines. And please note that remote sensing data cannot show the power poles because the power poles are very small. But you can go with the GPS and go with the map which is created with the GIS. You mark the location of the power pole, mark the location of the transformer, etc., etc., and you can make a very good power line with respect to that. Only thing is, with this work, you have to go on the ground. You can update the road network, you can update the water supply network, etc., etc. In almost all these type of things, GPS, in all these civil engineering type of application, GPS can be used.
Okay, thank you so much, sir. You have explained, I think, all the things in a very simple manner. First time, actually, I have heard very about the GPS and how to use it, how to apply it in our civil engineering. And actually, there is one more question from my side, actually, sir.
Okay.
what are the actually research areas that we can work in future in water resources or in civil engineering?
With GPS. Yeah, you see that GPS has opened so many research areas. First research area, if you remember that, I have shown you the L4 frequency, which is used for correcting the signal which is passing through atmosphere. All right. So through the atmosphere, when the signal passes, it attenuates. It means that it has got some deviation from the path. If you are having two frequencies, you can find out the impact of atmosphere over the signal. And this has also been used in other way. They are finding the precipitable water vapor using the GPS signal, because if there is more water vapor in the atmosphere, GPS signal will be deviated more. So indirect these computations are done to find out the precipitable water vapor, so that you can do the prediction for the rainfall, etc. That is one thing. GPS accuracy can be used as a new research here. Like you have to say that for a particular area, how much is the accuracy with this type of technique. When you are using the RTK, relative point positioning, when you are using the static positioning, what will be the difference of accuracy, etc. You can use it in the fleet management. You can use it for finding out location of an unknown point. Like you know the point where you have to go in the civil engineering project. You have to reach that place. Just by feeding the coordinate, you can go with that. So similarly, all these type of applications can be done with that.
Okay, thank you, sir, and we are very grateful to you, sir, for providing your precious time. I know we were very busy, and you have accepted our invitation, so we are very thankful to you, sir. And sir, we will be connecting you after actually some time, so we will be needed some details from your side. So
Sure. Sure.
thank you so much, sir. So now actually I will make some announcement to about the participants, because if there are so many participants that I have told you, around 5,000 people have registered for this workshop, and I know everyone will be benefited, and I hope that, and I do believe that you have explained everything, and or you can say some of them will have doubts, so they can contact you directly. So thank you so much, sir, and I'll be in touch with you, sir.
Goodbye to everybody. I hope this session is useful to all of you. All right. Thank you.
Thank you, sir.
Thank you, Rahul, sir. Very thank you.
Bye.
So I am requesting everyone, so please stay tuned. I would like to share some of the, you can say, some of the guidelines to you, those who have attended this workshop using YouTube or using Google Meet. We have actually will get the feedback of attendance from both of the sides. So there is one more request from your side to, you can say, there is feedback form that is actually already shared by Dr. Raji. So everyone has to fill that form according to your feedback form, as well as your attendance on Google Meet or on YouTube. We will actually give you the e-certificate. Okay, so within 2 day period of 2 days. If you will not get, you can contact Dr. Raji to clear your doubts. So we will distribute the certificates within 2 days. So we will take the feedback as well as your attendance on, maybe some of you have attended one session, some of you attended 2 sessions. So we will see the criteria, and we will, you can say, produce the certificates, and we will send you on your email whatever you have given to us. And so in the last, I would like to say vote of thanks. So first of all, I would like to express my sincere gratitude to our Honorable Director, Professor L.K. Avasti, who has given his blessings as well as support to conduct this workshop. And now I would like to say a special thanks to Professor R.D. Garg, who has given us a time and from his busy schedule because we were busy, very busy at that time. And I am also very thankful to Dr. Arpit Chokse and who has actually given his precious time because he was also working in some of the projects. So he has taken his time from his schedule and uh, and he has given very good presentation on how to use the GIS and remote sensing in water resources or hydrological modeling because nowadays it's very important. Whenever you will see in the future there will be a water scarcity, water problem. So that's why we need to make a plan. So as a civil engineer, we need to understand these things and we can learn from these new technologies because these are very new technology and that can be employed and that can be used in a very cheap manner. You know? So now I am also thankful to Dr. Gaurav Shukla who has given very good presentation about basics of remote sensing and GIS because whenever you will be knowing the basics, you can work further in different areas. You can choose your areas. Maybe you can work on urban planning. You can work on transportation planning. Maybe you can work on water resources planning. So there are different areas can be opened if you are having the basics of remote sensing and GIS. So I am also thankful to our head of the department, Dr. H.S. Chore, who has also given so much support and his also his encouragement that we are very thankful to him. So now I am also grateful to our all the experts, and now I would like to say thank you to all the participants. This is very good opportunity for me and for our organizing team to take care of you. I know some of them could not attend or some of them could not listen because of the internet connectivity or there are some other problems and there are some limitations of Google Meet. So we have tried our best to all you to engage in YouTube link. I hope we have done all well. If we have not done so, then we will try to improve in the next time. And so I am also thankful to our organizing team and all the people, those who have worked directly and indirectly. So now I am going to say once again thank you all the participants. Please keep in touch. If you are having any doubt, any discussion, you can talk to us. We are always available on. We have you can see, you can call us, you can email us. But please be in touch and what you try to learn these new things because this will be very helpful in basics of civil engineering or new advancements in civil engineering because these applications can simplify your work in future. Okay, so once again, thank you so much and be in touch. But please, I am requesting Dr. Rajiv if he wants to say something about this workshop or if he wants to ask anything to the some further processes. Dr. Rajiv, can you hear me?
Yes, I can hear you.
You would like to
Dear,
say something, please?
dear participants, if you want to say something, please tell me. You will get the certificate, that is 100% sure. So don't worry about the certificate. You will get the certificate within 2 days. If you are not getting the certificate within 2 days, please send me message or you can call me. If
Okay.
you want to say something, please tell.
Thank you, Dr. Mahesh Patil Saab and Dr. Rajiv Kumar Saab, your coordination and conducting of this one-day workshop smoothly. Thank you very much, sir. Thank you very much. This is Boganaidu from VBIT, Hyderabad.
Thank you, sir.
Okay. So, is there anyone would like to share the experience about this workshop?
Hello. So this one is a very beautiful workshop. I am Rijit Banik from Tripura Institute of Technology, one of the farthest part of our country, northeast Agartala, and this is a beautiful platform that I can listen the experts from the other part of the country, and we almost 250 participants are there in Google Meet, and some others could join YouTube live stream also. So I'm thanking to NIT Jalandhar and organizers for organizing such a beautiful workshop for us. And please do inform if this sort of activities are there in near future. Special thanks from our side. Thank you.
Thank you, sir. Let me inform you, Arjit sir, myself and Dr. Mahesh Patel, both are passed out from the IIT Guwahati. So we know the Agartala very well. So don't worry, we know your place. We have visited also. So we are familiar with this place. It's a very beautiful place. Northeast, it's a very beautiful place, sir. So thank you for attending this workshop.
Thank you.
There is one more request, everyone. Please fill the feedback form because without feedback form, we cannot issue the certificate. So please fill the feedback form first, and we are already having your attendance. So do not worry about the attendance. Everyone will get the certificate, and there may be some problem on our side. We could not answer your phones or emails, so we apologize for it. But I hope whatever the sessions we have actually delivered, they were actually useful to you, or they will be very useful in your future. So I am signing out. Thank you so much. Bye bye. Take care. God bless you.